Okay, 3, 2, 1. Hello world! Hi, it is Anthony as always. How was your January? This first January 2021. It was fine for me. Always at home, always working, and always preparing my lessons for you guys, because this is one of the most satisfying things that I'm doing so far. So let me switch immediately to the coding scene on what's this platform called? Twitch. You probably see some news going on, which I didn't have the chance to get used to. You will see something like gift a sub now to be number one, cheer now to be number one. I don't even actually know what this is. Hey Angelo, good morning folks. Same here, always at home, lol. Oh, that's awesome. You feel at home with us. That's beautiful. As far as I understood, I became an affiliate on Twitch, which means that I can start receiving gifts and cheers. There is this kind of a currency on Twitch in which it's called bits. You can buy bits for real currency, and you can cheer up your favorite streamers. I don't know. I don't care about this actually. Let's go back to the code and to the lessons. Last Wednesday we did a little bit of practice. We did a little bit of exercises on once again the check. Well, we did all the tasks that there were on javascript.info, but also we wanted to do a little more. So, for example, Bobby took this exercise here, check the login, which was a pretty complex and nested if-else cascade, and he wanted to welcome my challenge in trying to turn this thing into a ternary operator syntax, which is completely nuts. I hoped that it was clear to everyone that, especially with complex if-else cascades, turning this into a ternary operator is really insane. It doesn't make the code better. It actually makes it really, really worse. In fact, the ternary operator should be used only when you want to get or to declare a variable or to return a value which is subject to some condition. So if some condition is true, then you will return that value. Otherwise, you will return another value. But even if it can replace a complex if-else's cascade, what you get is pretty damn difficult to write and especially to read. So this was Bobby's attempt at turning the username, password, if-else cascade into a ternary operator. And I cannot understand it. The only way I could understand this thing is probably by adding a little bit of indentation, which is what I'm going to do right now. So, awesome attempt, Bobby. Thanks for your attempt. Thanks for your commitment. But I would say that this is an example of what you usually should never do outside of the academy. If you want to write good code, don't write it like this. If you want to learn how to write code, well, this is our purpose here. So you should do this kind of exercises because it's a way to improve yourself, right? So please, all these attempts are more than welcome. So let's try to indent this thing a little more. So I see let username is equal to prompt what is your username, let password, and then there's a ternary operator because I see a question mark here. So I'm going to add some indentation here because this is the true part of the ternary operator. And after the colon we have the false part. And here I see another ternary operator, so I'm going to put it on a new line here. The same goes with this column here, and then we've got another one here. And I'm going to indent it a little more in order to make it even more clear that this is subject to some other condition. Hey, Sao, good morning to you. And okay, this is the end of this ternary operator. So if username is null or username is an empty string, you can alert cancelled. Otherwise, if the username is not admin, then you can alert I don't know you. Otherwise, if the username is admin, then you ask for a password. Otherwise, there's nothing to do. So Bobby didn't know how to end this thing and he decided to return a null value. which is completely understandable. And this looks a bit like a hack because you don't use this null, but you needed this null to end this ternary operator. And that's one of the reasons why probably using a ternary operator in this case is not that good. The code is unreadable for two reasons. First of all, because the ternary operator is a long strip of things going on. And then also because you have to add some hacks, like this null that has no meaning other than a placeholder because you have no else condition, so you just put this. Let's see this other one here, username admin. I'm going to just add indentation without even understanding what this is about. I'm just adding indentation whenever I see a question mark or a colon. And one last one here. And I think we're done. So in this case, it says, if the user is admin and the password is null, or the password is an empty string, the password was gotten here somehow if we went here, but maybe we didn't get here, maybe we went into the null, or maybe we went into the alert or something else. So the password in this line 82 could actually be null or an empty string. Well, in that case, it will be alert cancelled. Otherwise, if the username is admin and the password is the correct one, then you're going to say welcome. Otherwise, if the username is admin and the password is not the master, but it's anything else, you're going to alert wrong password. Otherwise, well, there's no otherwise, so you just say null. This is a bit convoluted, and we could change it a little bit if we want to, just a little bit. But just to improve readability a little more. So, for example, let me see. One thing is this thing here. Username is null or username is empty string. This is totally fine. But if we want to, we can turn this into just username. Because if I use this expression here, username, the expression is a Boolean expression performed on a string, and it is true only if the string is not undefined, is not null, and is not an empty string. So with just the name of this variable, username, we already covered all the important cases. And the same can be done here. Password is null or password is empty string. You can say, well, in that case, it's exactly the same, the opposite. So password is null or password is empty string will give me a false if the password is null or is an empty string. So you can say, if there is no password, I'm going to use the not operator to negate the string. So if the string was a non-empty string, this is true, and I want to make it false. If the string was a null or an empty string, that's false, and I want to make it true with the not operator. These are all logical calculations that with time you will be able to do on the spot. It's this kind of recipes that we usually have. Password is null or password is empty string means that you can place a not wrapping everything and negate the two different parts, and also turning the or into an and. What did I do here? I applied De Morgan's law. De Morgan's law says that the negation, well, two elements negated in an and becomes the negation of the two negated elements in an or, and vice versa. We already saw this, and it's pretty handy sometimes. So not password, not null, and password not empty string. Well, this can be turned into just password, like we did for username, and now we just have not password. So we achieved the same results I was showing you a while ago. So small mathematical operations on this logic algebra, on this Boolean algebra, and it will get you into this. So this is not more readable. This is just more concise. Maybe we can do something more. So username, if there is a username, I always read it like this. If there is a username, and here I read it as if there is no password. which means that the password is not a non-empty string, is not a string. It's an empty string or null or undefined. Username alert cancelled. This is not true. Probably I had to do also here. Not username. I lost it. This was if not username. If there's no username, then I will alert cancelled. Otherwise, if the username is not admin, it will say I don't know you. Otherwise, if the username is admin, it will prompt for a password, otherwise null. But there's no null in this example here. There's an else that wasn't actually used in this ternary operator, but we can try to switch these conditions here so I don't need to add this extra null. So for example, I can say if the username is admin, then I will show you, I will ask for a password. So I'm gonna put this here. Otherwise, I'm going to alert I don't know you. So you see, if I just replace these things here, this is exactly what we wanted, and we don't need an extra ternary operator and an extra null. I'm using the this last element to say else. I'm not saying explicitly username is not admin, because if the username is admin, then I have to do this. And if the username is not admin, well, that's the else case. In any other case in which the username is a non-empty string, but it's not an admin, I will go into this path in the flow. I'm also going to put a semicolon just for completeness. Let's do the same thing here on the second one, and I'm also going to separate it a little bit with some extra new lines, so it looks more clear that these are two different blocks of code. Username is admin and we don't have a password. Okay, so in that case we do alert cancelled. If the username is admin and the password is the correct one, we alert welcome. That's fine. Otherwise, if the username is admin and the password is not the master, then I'm going to alert wrong password. Otherwise, it's null. Maybe we can do something similar to what we already said. But in this case, it's really, really more complicated. Maybe we can do something like this. I don't know. I can put a couple of parentheses, maybe. I don't know. I'm playing around. If the username is admin, this must be true. Username should be admin. And if the username is admin, then I can evaluate the rest of the expression. But the username is not admin, then I shouldn't do anything else. So here in this huge expression in parentheses, I'm going to check the password. And given for granted that the username is admin, and if I give for granted that the username is admin, then it means that I don't need to tell again, to check again if the username is admin or not. So I can remove this part because of course the username is admin if we have this expression which puts into an end the fact that the username is an admin and also we check the password. So we can put it here like this with parentheses, username is admin, and now if there's no password, I just alert cancelled. If the password is the master, then I'm gonna alert welcome. If the password is not the master, we can say the same thing that we said before. So the password is something else, and we don't need to say that it's different from the master. We can just say else. So I'm going to remove this condition and just put the alert, the last alert, in an else statement, in the else part of this ternary block. Okay, this could be good. So if the username is not admin, this was already tackled in here. Because if the user is not admin, is going to say, I don't know you. But if the user is admin, then I can continue with my calculations. So I'm going to check the password. And if the password is not there, I'm going to alert cancelled. Otherwise, if the password is the master, I'm going to alert welcome. Otherwise, I'm going to alert wrong password. This should work. And if you don't trust me, we can have a look. What is your username? I'm going to say nobody. I don't know you, and that's it. We got it. Again, what is your username? Admin. Password, I don't know. Wrong password, and it exits. It's strange that in the first run we had a false being returned from all of this, and on the second run we have an undefined. But this is because this false is whatever is returned by the last line of this expression. So in the first run we didn't put admin as the username, so this didn't do anything. No, well, it said I don't know you because the username was not admin. And then username is equal to admin is false. And in the end expression, as soon as you got a false, that value will be returned. So the false here is what is returned from username is equal to admin. In this other case, I said that the username is admin, so it's asked for a password here. And then username is admin, true, so I have to evaluate the second part of the expression, but this expression just went to wrong password, whose return value is undefined. So that's why I get an undefined here. Let's go with the normal flow, with the success flow. Admin, password, the master, and it says welcome, and it returns undefined because alerts return undefined. And if it's not clear what it means to alert to return false or undefined, don't worry, because we were going to look at it probably on the next lesson, which will be about functions. Okay, so this code works, but it's still ugly. One thing that I really don't like is the fact that the ternary operator is used mainly if you want to have a variable and the variable has a value which can be some value based on the truthness of a condition, otherwise it will be another value. Here we are using the ternary operator in an not so appropriate way, which doesn't mean it's wrong. It just means that it's less readable, less understandable, and it goes a little bit against the principle of least surprise. But still, I really welcome these kinds of attempts because it's a way for you guys to juggle with the syntax. So it makes you stronger. I don't know if I would do anything else. Probably I would do something like this also. Let password is equal to, and then I'm going to remove this password here. So in this case, what did I do? I said that the value of the password is, if there's no username, I'm going to alert cancelled, and since alert returns undefined, the password will be undefined. If username is admin, then I'm going to prompt for a password, and this will give me a value for the password. Otherwise, I'm going to alert, and then the password will be undefined. So this statement that I now wrote will give a value to the password only if the username is actually admin. Otherwise, the password will be undefined. Which means also that I probably can even remove this username is equal to admin, because if the user was not admin, then the password would be undefined. So I could probably even remove this one and remove the parentheses. And now I've got this other thing, which is a little more concise, but as you can see, the logic inside is a little more hidden. It's not really clear why the password should have a value by now if the username is actually admin. It works, but still, it's not really that readable. It's a little more concise, and if you compare it to this if-else cascade, maybe some of you could say that it's a little more readable than this thing here. But I don't know. I think that this is still more explicit, while this has some more implicit things going on. And so I wouldn't probably write it like this. We can write it some way else, which is probably with switches. And we're going to look at switches in a while. But first, let me run through the exercises about the calculator and the new exercise that I gave you, I think last Wednesday, which is about the generation. So, as for calculator, I saw 3 people sending me their attempts. They are all good attempts, very good. and they all look pretty much the same, but I still want to show them to you because I would like to show you how different people think differently. And I think that all your solutions were beautiful. My solution would be very stupid, very straightforward. Calculator is a web app that asks for two numbers and performs a specific operation to them. The available operations are sum, subtraction, multiplication, division, power, remainder, or what else you know. You can use an if-else cascade or the ternary operator, which is not recommended because the ternary operator is not a good fit when you have multiple if-elses. So what I would do is to get the first number, maybe let's num1, which is equal to prompt. Okay, if I read it correctly, let's say first operand, and it's going to give me the first operand. Then num2, which is the result of giving me the second operand. And that's fine. And what the text here doesn't say is that we need another input, which is the operation that we want to perform on these numbers. But all the attempts that I found made me understand that you already understood this problem. The requirements are not really that clear. There's an implicit thing, which is I also need to ask the user for the operation to do. So you got it completely correct. Awesome. So let's call it operation, and it's prompt of operation. Awesome. And now we can do the if-else cascade, in which, depending on the operation, we can just perform the operation. So I saw some of you do something like this. If operation is equal to, let's say, sum. I'm going to use the symbols here. If the operation is sum, then I'm going to alert num1 plus num2. Else, if the operation is equal to a subtraction, then I'm going to alert num1 minus num2, etc., etc. I'm not going to write everything because it's no use here. This is how I would solve it. I would like to stress a little bit on the spacing and the indentation more than the syntax itself. You probably understood the whole syntax. I saw some people using 2 equals instead of 3, which is fine, but I usually encourage you to still use the triple equals. I saw every single person doing the transformation, the conversion, explicit conversion from a string to a number, which is awesome. You didn't forget it, and that's awesome. I'm going to, to make it different, I'm going to use the plus here, which is not really that readable, but for my case, why not? So, very well done. Let's see your solutions. This is the first solution that I got from Tiago. And as you can see, it's exactly the same thing. Let operation type is getting the operation. Number 1 asks for the number 1. Number 2 asks for number 2. Then we've got the explicit conversion. And then we've got an if-else cascade in which the operation type is sum. Then I'm going to alert. Here, Tiago was even adding some strings. There's one thing that is missing here probably, because alert, as far as I know, accepts only one argument, one message, and here I see a string and then the operation. So I think that you want to concatenate maybe the string with the number that comes from here. But the problem is that since JavaScript is read from left to right, then this string will be concatenated with this number, which becomes a string, and this results in a string that will be concatenated to this other number. So if number 1 and number 2 were 1 and 2, this would be the result of the sum is 1, 2 concatenated. If you want to perform the calculation before concatenating, you can just put a couple of parentheses, and that's fine. Okay, so you perform the mathematical operation, 1 plus 2 is 3, and the result of the sum is concatenated to 3. And with every other operation, there's no such thing. What is alerted is just the result of that operation. So we've got a subtraction, we've got a multiplication, division, the power, which probably was like this, but I copied and pasted from Discord. So probably some of the symbols, the characters that you wrote were lost in the process. That's fine, don't worry. But if you want to paste any kind of code on Discord or on Slack or any other platform, I suggest you to wrap your code into backticks, like the template literal. So if you say let my code is equal to awesome, this thing that you paste on Discord will be shown as code. I'm going to do it live. So I'm on the JavaScript, putting it here. You see I'm putting the backticks. I don't need to put the new lines. As you can see, it's already in a different character, different font, different style. So as you can see, you just need to put a couple of backticks and your code will be recognized as code. I think that you can even put 3 backticks, and this will allow you to not only see the code as code, but also probably identify the kind of code that you want to... Yeah, you see, it's a block of code. It's a little different. This is some inline code that you can put in your text. So I'm going to show you let my code is equal to awesome. This is code that you can put in line with your common text. But if you put 3 backticks, then it will create a block of code and you can make it multi-line. So this is a suggestion for you guys. So this code is practically perfect. The only thing that I would probably do, just for the sake of indentation and for better readability, we usually put a space between the closing parentheses and the opening curly braces. But as you know, this has no effect whatsoever on the results of this code. It just makes it a little more air, Okay, so Tiago's solution was really, really good. I probably asked him at a certain point, hey, why if you don't alert every time? What if you store the results and then you alert only at the end? So this was Tiago's second attempt, which is creating multiple variables, one for each operation that was performed. So sum is num1 plus num2, subtraction is num1 minus num2, multiplication is num1 times num2, etc., etc. And then we still have multiple alerts. So what is wrong with this approach is, first of all, we didn't solve the problem if any problem was there. The problem that I was asking to solve was to remove all these alerts, but the alerts are still there. And also, we created multiple variables, which are the results of multiple operations. But I'm interested in only one operation. So a calculator that works like this would be quite an expensive calculator, because every time I want to perform an operation on this calculator, the calculator is still going to perform all the possible operations and then give me the results for the operations that I wanted. Which is not really that convenient. If my calculator is able to do 1,000 different types of operations, it will perform the 1,000 operations before and then just give me the results of the operation that I asked for. So probably not the best thing, but still, I love this kind of attempts because we can reason about them. And this is the final take on from Tiago, which I think is perfect. In fact, here we have a variable called final result. We don't care how this final result was calculated, not here. And then, depending on the operation type, the final result will hold the value, the result of the operation that we want, the sum, the subtraction, the multiplication, etc., etc. And then finally, I alert this final result. I think this code is perfect. I would just put those extra spaces just for the sake of, of my OCD. It's just because of my OCD. But I would like you guys to also start getting some OCD here. Okay, so this code is awesome. Let me see if there are any other codes. This is Sal's attempt, and I love this attempt. I love this solution because it shows Sal's creativity. I never asked for this message. Hi, I am a calculator. Let's do some calculations. But I love the fact that the message is there because the application seems more lively. It shows that it's an application that greets you and then it shows you what you can do. It's more usable. It's more user-friendly. And I love this kind of additions. I would say that this let user equal to is not really that important. You're not using the user variable anywhere in your code. And also the user will be undefined because alert is returning undefined. So this variable, I wouldn't put it. I would just remove it. Let operation is prompt. Please choose one of these operations: sum, subtraction, division, multiplication, power, or remainder. That's awesome. So you are even giving a hint on what the possible values could be. Hey, so I forgot to say that I changed the last if else to a else this way. Else operation is null. Result, please insert a valid operation. Okay, I'm going to see it in a while. Let num is equal to, whenever I say okay, my Android phone starts saying, hey, are you talking to me? No, I'm not talking to you. Let num is equal to prompt, please write the first number. Prompt, please write the second number with number 2. Then we've got this conversion, which is awesome. As always, just for the sake of my OCD, I would probably put these 2 lines indented at the same level of everything else, because otherwise they look like they are in a block inside of the line that is above them, which is not. And also I would put a little extra space here to just make them breathe a little more. But it's fine. It's completely fine. The code works. And then Sao came up with this variable result immediately. Awesome. And then we've got pretty much the same thing that we saw in Tiago's code. If the operation is sum, then you do result is equal to num1 plus num2. As always, I would put an extra space here, but just because I think it's more good looking, it's more standard, but that's fine. This is another difference in indentation. If operation is sum, result is equal to num1 plus num2, then we close the if, we go to a new line, and then we got an else if. This is good. It's a good way to separate the if and else ifs. I see that it's not really consistent. In fact, sometimes I see a new line, and sometimes I don't see a new line here. So sometimes it looks that this is a special block that should be separated from this kind of block, which should be separated by this one, and should be separated from this one, and also from this one too. Really don't see any huge difference between these operators. So either you put this extra space everywhere, or you remove it everywhere. I already told you about some conventions. There are some conventions, for example, the C language convention, which even makes you put the open curly brace on a new line, on a separate line. This makes the code breathe even more. But in Java, in C#, in JavaScript, we usually don't use this convention because we are just using too much space for JavaScript's taste. In fact, we even don't put this new line between the end of the if and the else. We put this like here, like this, with a space. I'm not saying that this code is not correct. In fact, it is. But for the sake of sticking to the standard convention, it is probably better to write it like this. The code doesn't breathe that much. I think that your code was breathing a little more, and I think that the body of these else ifs were more clear like this. But still, the convention is usually this one. And I'm talking about the convention because at a certain point in our course, we're going to start using some auto formatting tools that will follow those conventions. So if you are used to this convention here, then the auto formatter will just auto format your code using the convention that you're already used to. So I'm doing this for you, really. It's not just for my OCT. So in Sao's first attempt, there is unfortunately one thing that doesn't really work. We've got alert results, and then we've got a final message, alert, don't forget to study some math. And this is another very, very cute message that I love seeing at the end of the program. Probably this let final message, again, is not really that important because it's a variable that I'm still not going to use anywhere else, and its value is undefined because alert is returning undefined. So I'm just going to remove it. I like the fact that you put let final message in the sense that you try to convey the message that this is the final message. So you put this in a variable instead of using a comment maybe. But still, no real reason for this extra variable. In fact, later on, we're going to use some code checkers that will show you the potential errors and pitfalls that you introduced in your code, and creating, declaring variables that will never be used is usually shown as an error because you have this dangling variable that someone maybe could use in the future, and they're not supposed to use that variable in the future. It's just an extra variable that you forgot to remove. So let's just watch out for these things. It's really good that you created this code, so we can reason about it though. Okay, so what is the problem here? The only problem is in this else if. And Sao already corrected it more than once. I'm going to show you all the corrections and also the last one that Sao is telling us. So as you can see, there is an operation different from sum, comma, subtraction, comma, division, comma, multiplication, power, remainder. Although I see the intention here, this unfortunately is not valid JavaScript code. It looks a lot like natural language if the operation is not sum or subtraction or division or multiplication or power or remainder, but it's not how you write the code in JavaScript. In JavaScript, you have to be more explicit because the machine is a little more stupid than that. It cannot understand this kind of code. So what we want to do probably here is that we want to say that the operation is not sum, the operation is not subtraction, the operation is not division, is not multiplication, is not power, and it's not remainder. So we have to repeat this multiple times. And we have to repeat it every single time, unfortunately. Someone asked me, is there some way I can avoid to repeat this thing multiple times? Yes, there is a way to avoid this, and we're going to see it today. I would also put the usual, triple strict equality or strict inequality operator, because it's better to get used to it. And we've got another problem. The comma is not a valid operator between Boolean values. If you want to check if this is true or this is true and this is true, etc., you have to put at least an and or an or, not a comma. And I think that in Sao's second attempt, she did something like this. She used the or, which makes sense in the natural language, because if you try to read this, it makes sense. If the operation is not sum or subtraction or division or multiplication or power or remainder, it makes sense in English, but it doesn't make sense in programming. Again, we don't have this operation different from, and we have to repeat it. But also, the fact is that even if we had this operation different from, we should trap here the case in which the operation is neither of these values here. The operation should not be neither sum or subtraction or division or multiplication, but together. So the operation is not sum, and the operation is not subtraction, and the operation is not division. As you can see, I switched from or to and. And in fact, the last, well, not the last, but one other attempt by Sao is replacing all the ors with ands. this makes a lot more sense. The operation is not sum, and also the operation is not subtraction, and also the operation is not division, it's not multiplication, etc., etc. So these guys must be in an AND. I would ask myself, so why in English do we say or? Well, I think that the reason is that we probably in our mind say that it's not true. The operation is sum, or it is subtraction. Whoa. Nope. Okay. Or it is division, etc., etc. I'm not going to put everything. I'm writing in Italian. So when we say the operation is not sum or subtraction or division, we are actually saying that it is not true that the operation is sum or subtraction or division. But using De Morgan's laws, you know that the not of multiple ors is the end of all the operations of all the expressions negated. So one thing that I love about Boolean logic is that it forces us to think more logically and more strictly than we are used to. In fact, there is a common joke about, you know, the eggs and milk. Let's see, programmer, eggs, milk joke. My wife said, please go to the store and buy a carton of milk, and if they have eggs, get 6. I came back with 6 cartons of milk. She said, why in the hell did you buy 6 cartons of milk? Because they had eggs. Okay, this is usually how computers work. You try to convey a message in natural language, but if the message is not exactly clear as a machine would understand it, the machine would do something completely different. And sometimes programmers start thinking like machines, so they start abstracting too much from the real world and don't use their common sense. So this is what you could come up with also one day. I hope not. Try to keep human. But yeah, it happens sometimes. So as you can see here, the pitfall is that, yeah, buy a carton of milk, and if they have eggs, get 6. What is implicit here, it's that you have to get 6 eggs, not 6 cartons of milk. But since it's not clear, the programmer here took 6 cartons of milk, because they had eggs, which is completely stupid. So, as you can see, we should add the AND here. One small problem we have in this third attempt by Sao is that she used 1 ampersand only, which is a correct operator, but not a Boolean operator. This is a bitwise operator. This does an AND bit by bit, which you don't want to even know what it means. So remember, when you do an OR, you use 2 pipes. And when you do an AND, you use 2 ampersands. Otherwise, you are using operators that have nothing to do with Boolean logic. So watch out. But we're almost there. And in fact, Sao's last attempt was, well, just adding these ends here, and everything works exactly as it should. And I like the fact that Sao wanted to add this other case in which the operation was not a valid one. And finally, Sao says that she also did something like this. So I'm going to call it Sao 4. And Sao 4 is else operation is equal to empty string. I'm not sure that Sao really wrote it like this. Maybe she just tried to write it in a short time here on the chat. Maybe her real code is different. This is fine, but it has a few problems. I see at least 2 problems here. First of all, the else statement doesn't need any condition. The else, it means just otherwise. And if you want to put an extra condition, this should be an else if, because only the if has a condition. Else means in any other case, so we don't need any condition to say. And another problem that we have here is that here this is not an equality check. This is an assignment. So whatever the value of operation was, now it is being rewritten as an empty string. So this looks a lot like the problem that those scientists have with the crazy murdering robot, right? Is crazy murdering robot is false, but in the if condition, I'm saying is crazy murdering robot is equal to true, which is not equal. I'm assigning the new value true to the crazy murdering robot, which will kill humans. So in order to avoid killing humans, we have to put at least another equal symbol, or maybe even 3. Okay? So we have a strict equality. And this is better than probably this one, because in this case, we're not listing all the possible operations. We're just saying, hey, if the operation is not one of these and it's just an empty string, then just say invalid. Yes, it was triple equals. I just read it here and forgot. I assumed that. I was pretty sure that you didn't forget it in your real code. I don't know if you forgot the if here, but probably this is another miss that you've done in the chat, but not on your code. Okay. Another attempt could have been just an else with anything else. So you can have this, or you can have just an else in which you state whatever you want to state. This is good, unless you want to also check for the operation that is null because you pressed ESC or something like that. But still, this is fine. This is completely fine. And finally, we've got Bobby, who is fond of the var keyword and is fond of the ternary operator. So let me see what this is like. Var num1 is prompt. Please input your first number. I'm just joking. I want to be as strict as possible, just for the sake of learning. Number 1 is an explicit conversion into a number. Number 2 is please input your second number. Number 2 is number 2. Var operation is choose a mathematical operation. And I like this thing. As you can see, Bobby stated the possible values and he used the symbols instead of the whole word, which is actually what I did as my attempt. And he also wanted to play around with some mathematical functions that are available in the math object. We probably saw one of them. No, we just saw math.py. But we have functions like arctangent or I multiplication. We don't really care about what these are, but I like the fact that Bobby wanted to explore a little bit what the math object is able to do, and he successfully used these extra mathematical operations in this kind of in this exercise. And then we've got this huge ternary operator, which I cannot read unless I indent it a little more. So I'm going to indent it. Let's indent it blindly without even understanding what this is. Ooh, there's a lot of stuff going on here. I'm pretending I never saw this code before, but I actually did. Okay, I'm going to indent this. Okay. And then see how nested this is becoming. This is what I usually call a Hadouken code. It looks like a code that was pushed by the energy bubble, or you can also call it Kamehameha code if you like Dragon Ball. Okay, so probably this is how it goes. If operation is a plus, I'm going to alert num1 plus num2. If the operation is a minus, I'm going to alert num1 minus num2, and I'm going to add some extra spaces here. If the operation is a division and the two numbers are not 0, which is kind of clever, especially for the number 2, because you don't want to divide by 0. Or maybe yes. So you're going to divide number 1 by number 2. Actually, if the number 1 is 0, there's no problem. You divide 0 by any quantity and it's just 0. So I don't think this is an invalid value and should be listed as an invalid value. But still, we are not doing maths here. We're doing programming. Operation is asterisk, so we're going to do a multiplication. Oops. Operation is a power, and here I see the exponential operator being applied. The remainder, and here Bobby added the extra spaces that I really like. And then he wanted also to explore other functions, other mathematical functions. So operation is arc10, and he alerted math.atan2 num1 num2. Whatever this means, we don't care about what it means right now. Operation is imul. Math is alert math imul num1 num2. Operation is an empty string, alert error, otherwise invalid input. Okay, so good. Still, this huge train is not really readable. We've got some extra space here. We could fit Harry Potter in this place. Why would you need to use a calculator to divide 0 and get 0? Well, because the calculator should allow you to do whatever you want. So if you have a real calculator at home, you can divide 0 by any quantity and it will give you 0. Because maybe you are learning maths for the first time and you want to see what 0 divided by any number is. 0 divided by pi. Maybe you don't remember and you do it on the calculator. And, well, actually also divided by 0 could be interesting. Because divided by 0 should give you, I think, not a number. Let's find out again. 6 divided by 0. No, it's infinity. So infinity in some calculators is a valid value. But if you're doing maths from first grade, probably the result of dividing 6 by 0 is no, you cannot do it because teachers do not want to give kids the concept of infinity yet. They will explain it later on. But still, everything is perfectly cool here. And I think that Bobby wanted to explore a little more about this division by 0 or other strange results. So there's another attempt here, which is in fact turning the ternary operator into an if-else cascade. I love this code too, because it gives me the chance to show you something even different. As you can see, we've got 3 different people. Each one of them created multiple different solutions, and every one of these solutions is important and interesting per se. So here we've got the numbers that are prompted and converted. Then we've got the operation. Then we've got the total, the variable that will store the result of the operation. Then we've got this if-else cascade. But in the case of the division, we also see something going on here. There's an alert that is going to tell you, no, you cannot divide by 0. And then we've got something else here going on, which is interesting. So first of all, one problem that I see in this code is, as always, indentation. It looks like the if I'm not reading the whole code, if I'm just having a glance on this code, I'm seeing that there's an if, and inside of this if, there's a whole block of things inside of it. And the whole block ends here, because here we've got an else, which is at the same level of this if. So it looks like this is a huge if containing sub if-else statements, but it's not. This is suggested by indentation, but if you correct the indentation, it tells a different story. In fact, I can put this curly braces on a new line, and I will see that this else if is actually not inside of the if, but it's at the same level. So we need to take care of this indentation, because otherwise it's going to suggest us something that is actually different from what is the intended code. We've got some other indentation issues here. The total should be, this computation should be indented more compared to the else if, because this makes it more clear that this is the body of the if if statement. The body is inside of the if statement, and to make it more clear that it's inside, you indent it a little more. So this is what indentation means. You have to, anything is indented a little more because it's inside something. And if it's not indented more, it means that it's not inside, it's side to side, just like in HTML. This is pretty important, not for just for readability purposes, but also because if you use other languages such as Python or Ruby, well, in Python and Ruby, you don't have curly braces to tell the computer where a block ends and starts. You rely on indentation. So indentation is part of the syntax in Python and Ruby, and you have to make sure that your indentation is as accurate as possible in those languages. Otherwise, things will not work. Here in JavaScript, things work, but they are less readable to a human being. In other languages such as Python and Ruby, those things will not even work. So it's much, much better if you learn from the start to indent everything perfectly. Really, trust me. Okay, so I'm going to correct the indentation here a little more. I hope that you got what I'm saying. If not, please tell me. And I think we got here. Then this else is also part of this if-else statement, apparently. It's the last else. We can also add an extra space here. No, it's not. You see, this alert is also part of the else, because here we've got a few problems, but let's say that this alert is part of the else, so I should put a couple of curly braces in here to make it clear that the alert is a child of the else statement. And then we can start fixing some of the problems that we see here. So, for example, everything's perfect here so far. If the operation is a division and the numbers are both different from 0, then I can perform the division. But if the operation is still a division or the number 1 is 0 or the number 2 is 0, you are going to say I cannot divide by 0. This statement, I don't like it that much. In fact, I think that you probably fixed it later on, if I remember correctly. If the operation is a division or the number 1 is 0 or the number 2 is 0, means that I'm going to do this alert if the operation is a division, or if number 1 is 0, which means that the operation can also not be a division. Maybe it's a remainder with a number 1 of 0, or number 2 is 0, which can mean that the second operand is 0 and the operation can also not be a division, and number 1 can also not be a 0. This is not what you want. Probably what you wanted to do is, again, an AND between these things, because you don't want to perform the division if the operation is a division and also the number 1 is 0 and also the number 2 is 0. But still, the alert says cannot divide by 0. And so who cares about the fact that number 1 is 0? If number 1 is 0, you're not dividing by 0. You're dividing by 0 if number 2 is 0. So I would even remove this part, this fact that number 1 is equal or different from 0. If number 1 is equal to 0, well, the result will be 0, but it's not a division by 0. It's actually a perfectly fine result. If you want to say it's no use to divide 0 by anything, then you can put this extra else if you want. Else if operation is equal to division and number 1 is equal to 0. If you really care about this, then you can say alert, why are you dividing 0 by anything? Okay, so you can tackle this other thing, but it's not in the scope of dividing by 0. You are dividing 0 by something else. So you are alerting things, and then finally you alert the total if the total is actually a number, because if if the operation, for some reason, for example, here, if the operation was a division and the number was 0, you are alerting, cannot divide by 0, and the total, which was undefined at first, is still undefined. So here, probably you wanted to check if the type of the total is a number, because if it's a number, then some operation was performed, and then you want to alert the total. But if the total is not a number because it's undefined, then you don't want to alert the total. You already alerted, cannot divide by 0. And here we've got a couple of problems. First of all, the else doesn't need any condition. You either say else, or if you want a condition, you have to add an if. Else, if also this condition is true, then you alert the total. This is the first problem. And the second problem is that total is the reference to the variable. And if you write this thing here, it's going to compare the value stored in this variable with this string number. So let's say that num1 plus num2 gave me the number 5. You are comparing the number 5 with the string number, and they are completely different. What you want to do instead is to check the type of the variable, not its value. And to check the type of a variable, we already saw that there is a special keyword called type of. So this is going to compare the type of total, and the type of 5 is actually the string number, with number. I'm going to also put an extra equals here, and I think this is perfectly fine. So I think that this code is really, really well done. It had only a couple of indentation problems, and also watch out for the logic here, because maybe it didn't convey exactly the message that you wanted to convey. And finally, also this other thing here. But I like the fact that you tried to get to put this extra feature of checking for operations that you are not allowed to perform. This is awesome. And as we already discussed privately, Bobby, it's pretty strange to do something like this. What you are trying to create is to address an exception to the normal flow of execution. And in JavaScript, in other programming languages, there is this concept called exceptions, or probably in JavaScript they are just called errors. And we're going to look at them. Errors, the error object is able to is going to allow you to express those special cases in a more convenient way. So very good attempt, and keep this in mind, because one day we're going to look at errors and you'll say, oh, so this is how I should refactor my code using errors, and it makes more sense. And this is one other attempt from Bobby. Probably the last, no, not the last one, but also almost. Here we still got some indentation issues as always. Here we've got the same problem that we have had before. And here Bobby tried to use some new syntax concepts like this keyword called throw. Throw is strictly related to the concept of errors. But as always, if you're using keywords that I didn't explain, it's like you are trying to solve a puzzle and to play a game with cheat codes. You have to try and fix things with the tools that I provided so far, and then I will give you more tools. But still, this means that you looked on the internet and tried to find a solution by yourself, and you found a good solution. So kudos to you. Really, there's no wrong or right way to do things. One thing that I really care about, the right thing, is that you explore things, that you browse the internet and find the solutions by yourself. This is what make you good developers. Finally, this is the last one, yeah? Last attempt by Bobby is exactly the fixing this problem with the type. It's actually a little different because there's just an if instead of an else if. And it's probably better. Okay, a klaxon is honking. This is probably better. It means that this is an if-else cascade, and only at the end of the whole if-else cascade, I'm going to check what is the final value of total. The total has a type of number, then I'm going to alert the total. Otherwise, I'm not doing anything. In fact, I think that my solution, the solution that I changed here, this is really bad. Because if the operation is plus, I'm going to do this. Otherwise, I'm going to do that. I'm going to do that. And finally, if the total is a type of number, I'm going to alert total. I'm never going to have a type of total equal to number in this case. What does this code mean? It means that every single condition here was not satisfied. So I cascaded from condition to condition until I found this condition here. And if I got here, it means that the operation that was input by the user was not a plus, was not a minus, was not an asterisk, etc., etc. Maybe it was something completely different. It was Pikachu. So if the user input Pikachu, here I'm going to say, is the total type of a type of number? No, it's not, because it's started as an undefined, and I never ran into any of these if-elses, so the total was never changed. So this is never going to be executed. What I wanted instead is to process all of this if-else cascade, and at the end of this block of code, something happened. Either the total was calculated because the operation was, for example, a subtraction, so the total has now a value, a numeric value, or maybe the total was never calculated because I went into, for example, this condition here, so I'm alerting something and the total was never updated. So at the end of the whole block, I am finally inspecting the type of the total. And I'm doing it in a separate if-else cascade. I can even put another else here. Alert, something went wrong. Okay, so Bobby's attempt here is really, really interesting because it shows you that in the same code, you could have multiple if-else cascades. It could have a nested if-else cascades, just like in the check login, this one here. Or you can have one if-else cascade and then another one that will be executed and interpreted right after the whole if-else cascade was computed. Okay, so this is the final version of Bobby. That's apart from the indentation and something that I don't really agree with the logic is the proper solution. You have an if-else cascade, and only at the end, I'm also checking the type of the total and checking if it's a number, because if it's a number, I want to alert the total. Otherwise, I will have already alerted can divide by 0 or even invalid input. Okay. Finally, generation. Generation is the exercise that I gave you at the end of last Wednesday, and generation is finally what I wanted Gen Z to be. If you remember, Gen Z was a very stupid. Where was that? I cannot find it. I will find it. Oh, Gen Z, he's here. Gen Z was a stupid exercise, and it was even not correct. It asked for the year of birth, and then is Gen Z is true only if year of birth is greater than 2000, which is not even true. So generation is an exercise that checks the real generations that we found on Wikipedia. Apparently, there's the lost generation. There's people born between 1883 and 1900. Greatest generation is from 1901 to 1927. Silent generation is between 1928 and 1945. Baby boomers is between 1946 and 1964. Generation X, millennials, zoomers, and then we've got also Generation Alpha, which overlaps by a bit, by 2 years. Zoomers end in 2012, but Generation Alpha starts from 2010 for some reason. I don't really know why, but still there is some overlapping. So this is really, really similar to Gen Z, but in this case we have to do an if-else to show what is the generation the user belongs to. I'm not going to show my code. I'm just going to show your code, guys. This is Bobby's first attempt, which, as always, is with the ternary operator. I will go back to it later. I want to show Bobby's solution with the if-else cascade, which I think is much more interesting. I'm going to check the year, and in here, Bobby added some more explanatory message, which I really love. To check how the generation you are born in is called, please add a year of birth between 1883 and 2021. This is really good because it tells you what kind of years you can put. You cannot put 2022, for example, or a date before 1883 because it will never be able to calculate it. Then the year is converted into a number. And finally, we've got an if-else cascade in which we see that the year is between two numbers. So the year is between 1883 and 900. And then in that case, I will alert lost generation. If the year is between 1901 and 1927, I'm going to alert greatest generation, etc., until we get to the part in which the two dates overlap. In that case, what happens? Bobby decided to split the overlap into its own if condition, which I think is really, really clever. So, as you can see here, between 1997 and 2009, we've got Zoomers. Between 2010 and 2012, which is the intersection, then we say Zoomers and Generation Alpha overlap here. And between 2013 and 2021, we've got Generation Alpha. So if we've got these two sets, which are Zoomers and Generation Alpha, there is a bit where they overlap somehow, and this overlapping, this intersection is tackled in its own if condition. I think this is probably the best way to address this overlapping. And finally, we've got an else that says just invalid input. I think this code is pretty perfect, except for just minor indentation stuff. As always, I would prefer to put this extra space here between the closing parentheses and curly braces. And in the else, I would still put a couple of curly braces to wrap the else statement. And this is because if you say alert invalid input and then alert all done, it looks like this second alert is part of this else statement, but it's not. The indentation is tricking you. The indentation should make it really clear that this alert is going to be executed regardless of what is inside of the else. And the curly braces make it even more clear that the only thing that is going to be executed in the else statement is this alert and not this one. So indentation, as always, is pretty important for readability. But this code is awesome. I would have done it exactly like this, probably. Angelo, I know in Excel VBA there is a command called select case, which is similar to if else. Is there an equivalent in JavaScript, or do you always use if else? Select case looks a lot like a switch statement in JavaScript, which is the next topic that I'm going to cover. There is one thing called nullish coalescing operator, but this is a recent addition to the language. I never used it in my life, but I wanted to mention it because I found this beautiful GIF about Italians using the double question mark. But it's not really that important as an operator. If you want, I'm leaving it there as an optional operator that you can learn. I think that probably 80% of JavaScript developers out there don't even know that this nullish coalescing operator even exists. And the nullish coalescing operator is something that checks if a variable is null and undefined, and if it's not null and it is not undefined, then it's going to use the variable a. Otherwise, it's going to use another variable called b. So if you say result is a question mark b, then it means that if a has a value, I'm going to use a. Otherwise, I'm going to use b. So for example, let user alert user question mark anonymous. If the user was never defined, like in this case, it's going to give me anonymous. But if the user was defined, then I'm going to use user instead of anonymous. So it's just a way to make things even shorter. You can do this with the ternary operator. You can use it by explicitly saying everything. You can even make it less explicit by saying A different from null without strict equality, which takes both null and undefined, as you know. But still, I don't think it's really that important to know this. As you can see, first name, question mark, last name, question mark, nickname, question mark, anonymous. You can do this huge chain that is going to check if the first name is not a null or an undefined value. In that case, it's going to use the first name. So if you want to greet the user that just logged in, you can say, hello, Anthony. But if I didn't put my first name, then it will say, hello, Mistretta, which is my last name. But if I didn't even put my last name in the system, then it's going to try with my nickname, which is, well, supercoder, Ice on Fire. And it will say, hello, Ice on Fire. And if I didn't put either my first name, last name, or nickname, it will just say, hello, anonymous user, okay? Why I don't ever use this? Well, because I usually prefer to use the or. Thanks for explaining, but it sounds like if else is the standard go-to when checking for different scenarios cases. No, I didn't even, wait a second. I'm going to tell you about switch. I didn't get into the switch. I'm going to run through this really quickly, and then we'll go to the switch. Sorry, it wasn't really clear. Let's finish this one here for now. So the nullish coalescing operator is not really that important, especially for strings, because usually I prefer truthy and falsy value. If I put ors in here, I'm checking if first name is either undefined or null or even an empty string, which usually means that I still haven't input my first name. So I usually write things like this: first name or last name or nickname or anonymous. There is a slight difference because this is also checking for empty strings. This is only checking for undefined and null, not empty strings. If the string is there but is empty, it is considered a value. And that's it. I don't really care about this nullish coalescing operator. But let's skip loops for now, and let's go to the switch statement. The switch statement looks a lot like the Visual Basic script that you were mentioning, select case. In fact, one of the two keywords that you mentioned is actually part of the statement. It's not the select. Here we say switch, but we've got case. So the syntax is something like this: switch some expression, and in brackets you have case some value, colon, and you do something, whatever you want, and then optionally you do break. Let's say that for now we will always write also this break, and I'm going to tell you what this means. And then you've got another case, and then break. And then you also got a default. And well, this optional break is completely stupid. I will never write a break here because we are at the last element of the switch case. Switch case is just one fancy way to write if-else cascades, and it allows you to not repeat yourself. So this is a common alternative, and Bobby already knows that using if-else statements, ternary operator, and switch case will create spaghetti code. There's even a website called Anti-If Campaign that discourages you to use if-elses and switches and ternary operators in your code. But what this Anti-If Campaign does is to encourage you to use other means in object-oriented programming to make your code more flexible. But for now, we are creating simple algorithms, simple plans with steps to follow, and you cannot improve those algorithms. You should try as much as you can to not use if and else's in a different scenario, which is object-oriented programming, designing complex software by defining objects that interact with each other, which is a more complex scenario that we haven't touched yet. So don't really care about the fact that you shouldn't use if and else's. In fact, this procedural way of writing code with if and else's is now really important, and it's even became more mainstream. For example, in this library is called Redux. It's a library, let's say, by Facebook, and it's a library widely known and widely used by front-end developers. And if you see the code, you will have a lot of those switch cases. So switch case is really important and even encouraged, and it's even recommended in some scenarios, like in functional programming, because Redux is all about using functional programming for building beautiful and powerful interfaces. So please don't believe anything you see on the internet. You will see people saying, no, the switch case is awful. Yes, it is, but only in some cases. The switch case is really, really good and important and useful in some other cases. So the bottom line here is, please learn everything. And then, based on this different scenario, you will learn to tell what is more convenient and what is less convenient. So switch case. Switch case is an alternative way to do multiple if checks. But it's a special case of the if-else because it just checks for equality. If you have a variable here, if x is a variable, then you're checking if the variable is equal to value 1. And if it's not equal to value 1, then you'll check if it's equal to value 2. And if it's not equal to value 2, then you will check for other cases. And by default, this is the else statement. If the variable is not equal to any of the value that I provided here, then I will do something else. Okay? The difference is that the comparison here is just for equality. You cannot, in the switch case, say if the year is greater than something. If you have to check for something that is not equality, but it's a greater than, less than, or anything else, matches a pattern or something else, you cannot use the switch case. This is just a particular application of the if-else cascade. So let's see this example. Let a is equal to 2 plus 2. So a will be 4. Switch the value of a. If it's the case of 3, which means if the value of a is equal to 3, then I'm going to alert too small. If the value is 4, which is our case, because a 2 plus 2 is 4, it will say alert exactly. If the case is 5, then it will alert too big, but this is not our case. And if it's not 3 or 4 or 5, in any other case, this is the default case, it will alert I don't know such values. I didn't tell you what the break is. Well, break is a special keyword that is used to break execution, to stop execution there. So if you put the break here, and the case was actually 3, it will alert too small, and then it will break the switch statement, so it will not continue with all the other cases, because I already found my case. So it will go at the bottom of the switch, and will resume execution with whatever we had below the switch. If I don't put a break, then it will look for case 3, and if it's true, it will alert too small. But then it will continue comparing a to 4 also, which usually we don't care about, because if it was 3, then it will never be also 4. The problem is with the default. Default takes every scenario. So if, for example, if you remove the break from here and the case 5 was true, then it will alert too big, and without breaking, it will also execute the default. So this will be executed nonetheless. So it's a bit tricky. It's just syntax, and you have to learn it by heart, and that's it. So I'm going to do it here. I'm going to create a new folder called 13 fundamentals again. You see how many days we are spending in fundamentals, because they are fundamental. This is the switch. Can you see me switching on? Okay, let's switch like this. Okay, can you push the button? A is equal to 2 plus 2. I'm going to try this code in here. Let a is equal to 2 plus 2. I'm going to switch the value of a and see what happens. It says exactly. Why does it say exactly? Because let a is equal to 2 plus 2 is 4. I'm switching the value of a. It's not 3, so I'm not going into this path. It is 4, and it's going to alert exactly, but it's also breaking execution. So whatever it says here below will completely be discarded. And that's it. But then we can say alert let a is 5, and it says too big. Why does it say too big? Because case 3 is not true, case 4 is not true, case 5 is true, and it's going to alert too big, but also break, so it's not going into the default. Let's see what happens if I say let a is equal to 5, but no break. It says too big, but also I don't know such values. As you can see, the break allowed me to interrupt the execution of the switch statement. And if I remove it, then it will go into case 5, alert too big, but it will also go to the default, alert I don't know such values. And this is not the case in which this does not apply only if the case is right next to the default. I can probably remove also this one here. And let's see what happens. Exactly. But also don't too big. What? So what happened? Case 4, it alerted exactly. But then it also went here. And why is that? It says that if case is 5, I should alert too big. And the case was not 5. Well, the reason why this worked is that if I write things like this, you can refactor this code by moving this case 5 here. And this is exactly what happened. This code says, if the case is 3, then I will say too small, and then I will break. If the case is 4, or the case is 5, then I'm going to do these things together. So don't get tricked by the syntax here. It looks like they are different cases, but instead, this is actually an OR between two cases. So if the value of a is either 4 or 5, then I will do these things here. So it's a bit tricky. The switch is a bit tricky, and I really, really encourage you to do some experiments on this, because maybe it looks kind of easy when I use it, but when you try it, maybe you could find some strange pitfalls. And as you can see here, it's explaining exactly what I told you. Here, all the breaks were removed. And what happens is that this looks like if case is 3 or case is 4 or case is 5, then alert too small, alert exactly, and alert too big. So, and even I don't know such value. So it's going to alert everything. Well, starting from case 4, I think. Yeah, 2 plus 2 is 4. So the case 3 is not going to be addressed, but still, from 4 to the rest, I'm going to write everything here. It's strange. It is quite strange, and you can do very strange stuff. In the switch, you can put any expression, not just the name of a variable, but also, for example, in this case, the result of converting this variable into a number. And in the case, you can put any expression, for example, this sum between numbers. You can do whatever you want. It's pretty strange. And as you can see here, the grouping of case is made like this. Case 4, alert right. Otherwise, if case is 3 or case is 5, then I'm going to alert these two things, but still I'm going to break. And by default, I'm going to do something else. As you can see, this is really, really similar to what I wrote in my code, case 4 and case 5. To make it even more clear from an indentation point of view, it's usually much better to separate the different cases and the default with a new line. So this way it looks way more clear that this is a case that comprises 4 and also 5, and this is another case, which is the default case. The type matters. Yes, in fact, of course, if you prompt a value and the value is a string, so case 0 or case 1 will be tackled, case 2 will be tackled, case 3 will never be executed because I never converted the argument into a number. So watch out, because the type matters, just like in if-else cascades. And that's it. I don't want to go too much in detail on this, except for maybe do one exercise on refactoring what we already have. And let's try, for example, with the calculator, okay? I'm going to create a new calculator here. New file, calculator.js. So the calculator is, of course, the same exact scenario, but this time I would like to use a switch. This time, let's use a switch statement. Okay, so let's find out. We have to get two numbers and the kind of operation that we want to perform on these two numbers. I'm going to write them as always like let num1 is equal to, I'm going to do the conversion with the plus. Still, not suggesting to use this, but it's so convenient for me right now. Let num1 is equal to plus prompt first operand. I'm going to do the same with num2. You can just copy paste whatever you have on your code if you don't want to copy exactly every single character that I have. In the meantime, Angelo, was this now answering your question, your initial question? Is this similar to the select case you were mentioning in VBA? Yes, perfect, thanks, awesome. Okay, let num is the result of transforming into a number first operand. Let num2, same thing. Then let's do a let operation is equal to prompting the user but not converting into a number, because this will be actually a string operation. And this is gathering input from the user. Now, I want to check what is the value of the operation, and based on the value of the operation, I want to perform the calculation and store it in a variable that I will call result. So, how do I create this code without an if-else? I'm using switch. So, switch, and in parentheses, I'm adding the expression that has to be tested. In this case, the expression is just the value of the operation. I want to check the value of the variable operation and see if it corresponds to any of the cases that I'm going to list here. The first value is case string plus, or sum if you like it. If you prefer to use the whole word, just use sum. I'm going to use plus because it's fewer characters to write. So case plus, I'm going on a new line. This time I don't use curly braces. Sometimes it's convenient. You can use curly braces in here, but I usually don't see those, so I'm not using them. Okay, so just using case plus and no curly braces. And if the case is plus, then I'm doing result is equal to num1 plus num2, as you already know. And I have to remember to break. I need to break. Otherwise, this case will be attached to the case that I'm going to describe immediately after. Now I'm going to say case minus colon. On a new line, I'm going to say result is equal to num1 minus num2. And then break again, etc., etc. As you can see, the syntax is pretty strange. The indentation is not really that simple to achieve, especially here on Visual Studio Code, which is trying to add indentation where it's not needed. For example, if I go on a new line, then I'm going to write case multiplication here, but this case, as you can see, is indented too much. It looks like it's a case inside of this other case. It's not. So I have to indent it less explicitly for some reason. And in this case, then inside of the case, I have to put the expression, which should probably be indented a little more, just to say that this is part of this case, of this scenario. num1 asterisk num2, and then break. And then you can put whatever other cases you want. I'm not going to list them all because there are too many. And then usually it's better to also add a default case. The default case is the else in the switch statement. And it's always a good idea to use a default scenario. The default scenario could be anything. You can, for example, alerts invalid operation. Okay? And if you want, you can mix switches and ifs together. For example, Bobby found this cool idea of saying if the type of the result is a number, then I'm going to do something with it. For example, I'm going to alert it. Why not? And maybe I can even, I'm going to put it in a template literal so we can rehearse this. The result is number. I know I wrote it really fast, but I'm going to stop here, so don't worry. You see, you can mix switches, if-elses, ternary operators. You can put an if inside of here. It makes the code really, really less readable, but you can. So you can do whatever you want. The only thing that you cannot do here is, for example, to check for greater than, less than, perform anything that is not a strict equality operation. But in this case, as you can see, the code is a little simpler than doing this else if operation is not plus, is not minus, is not asterisk, is not blah, 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 blah. You're not repeating operation is equal to. You're just switching operation and then using the cases without repeating operation. I saw some rookies doing something like this. This is not correct. Case operation is equal to plus. I don't need to state operation is equal to, because this is implicit in the switch statement. Switch operation, case plus. This already means that the operation is compared to plus. Okay? So that's why you have to try the code yourself, because you could incur in these mistakes, which I incurred many times at first, and you have to have a gut feel of the fact that if you see something like this is not looking good. Okay? At first, it looks exactly the same as everything else because it's not part of your language. But at a certain point, once you saw this bad code multiple times, you will see at a glance that this has something wrong inside of it. And instead, it should be like this. Let's see if this works. New tab. I'm going to refresh everything. Okay, first operand, 3. Second operand, 4. Operation, asterisk. Number is not defined. Awesome. I said number here, but it should have been results. This is pretty stupid. The result is number, but number was never defined. So I had to put results. Luckily, JavaScript told me exactly what happened. On line 25, which in my case is 41 here, but in this code, it probably is the 25th line, I was referencing a variable that I never declared before. So this was the problem with my code. I'm going to copy that again. I'm going to refresh everything. And let's try again. 3, 4, and multiplication. The result is 12. Awesome. And if I try again with some operation that I don't have, let's do, the arctangent as Bobby did. Second operand. Oh, that was that was one of the numbers. Okay. Operation invalid operation. It's still going to say invalid operation because the operation was not valid. What happens if I do a valid operation between two numbers that are not numbers? For example, 1 in letters and 3 in letters, and I want to sum them. The result is not a number. It is a valid result, but it's not a number. which means that probably I should also do some check on the numbers too, which I can do pretty easily. I can do, I don't know, something like an if here. If the number 1, how can I say that the number is a valid number? There are multiple ways, but the problem is that I cannot say type of num1 is number. Why can I not say, why can I not use this? Type of num1 is equal to number. Then the number is a valid number. Well, this is not helping me that much, because if I do type of not a number, it's going to say that this is a number. This is pretty stupid, but it's part of the JavaScript language and was never fixed because of backwards compatibility. So if I want to check that the number is not a number, I have to find another way. What is this way? Well, this way is Googling stuff. Check if number is not none in JavaScript. Oh, okay. Apparently there is a function here that we never saw before. It's called isNone, that checks if anything that I put inside of it is actually not a number or not. So isNone of 1, 2, 3 is not a number because it's a number. IsNone of -1.23 is false because this is a valid number. 5 minus 2 is a number. 0 is a number. Even a string is not a number. Well, no, this is converted into a number, so this is why it's false. But a string that is converted into a number, then it is not a number, apparently. So this is exactly what we want. A none is a none. Even divided 0 by 0 is a none. But not null. Null is actually considered a valid number. Okay, so this function can probably suit my needs, and I can just use it like this. Instead of saying type of num1 is number, I can say if is none of num1, this checks if the number was not converted into a real number. And I can do if not is none to say that if this number is a valid number. Too complex here, we can split it into multiple variables and make more sense of it. For example, I can create a variable called, I don't know, is valid. Let's say is num1 valid. Is num1 valid is a Boolean variable that tells me that the number 1 is a valid number. And what's the result of this? Well, it's exactly this thing here. The number 1 is valid if the number 1 is not a number. Or you can make it like this, which is exactly the same. Is num1 valid checks if checking number 1 against not a number says no, this is not a number. It's not true that number 1 is not a number. You can write it however you want. I prefer the most concise way, but I can understand if this is way too more complicated and convoluted. You can write it in a different way. You can do the same thing for num2. It's exactly the same. Not is none. Watch out, because the n's should be both capital and the a should be lowercase, otherwise it won't work. You remember, JavaScript is case sensitive, so it's very sensitive, and you cannot use capitals and lowercase letters as you wish. So now that we've got these two, I want to perform all these operations only if the two numbers are valid numbers. Otherwise, I don't want the code to be executed, to be performed onto non-valid numbers. So I can do an if is num1 valid and is num2 valid. So if both numbers are valid, then what am I going to do inside of here? Well, I'm going to cut and paste everything that I wrote so far, and I'm going to put it here inside of it, because this means that these whole calculations will be performed not always, but only if this condition is true. Otherwise, I can put an else in here. I'm going to alert something else, like invalid input. Invalid input numbers, let's say. Okay, so if the numbers are valid, I'm going to perform the calculations. If the numbers are not valid, I'm going to just alert invalid input numbers, and that's fine. If the numbers are valid, I'm going to do the operation, and if the operation was not a correct one, I'm still going to say invalid operation. As you can see, this if contains everything. Can I turn it into a switch? Not really, because I'm not checking for the value of this number 1, and I'm not checking it against something else. I'm checking the type of this number. I'm using a complex function here that is checking if the number is not a number, and then I'm negating this thing. This is one of those cases in which I cannot turn this if-else into a switch statement. I used to say you cannot do comparison with greater than or less than, but any kind of comparison, such as this one, cannot be performed with a switch case. You still have to use an if. So the switch case is just a special case of if-else, in which you're doing comparison with just strictly equals, and it's more readable in some cases. You want to prefer it to the if-else cascade in certain cases. Otherwise, you're just going to use if-else, the most general way. Okay? I went pretty fast on this, but it's also because I want to make things run faster and faster the more we go. We're going to go a little slower with loops, because loops are our first big boss in this academy. They are pretty difficult. Not the syntax itself, but what you can do with loops. You can do almost everything with loops. And so we're going to look at a lot of different algorithms and recipes that you can do with loops. Loops are really the huge meat of any programming activity. So I hope this switch is clear, at least for the syntax. I encourage you to do some exercises on this, because the tricky part here is to get the syntax correct. But I think that the logic behind it is not really that different or that difficult compared to the if-else statements. Still, if you have any problems, just tell me, and I will make sure that you're on the right track again. So that was the switch statement, and we've got tasks to do, so please do the tasks and we'll correct them next Wednesday. One task is to rewrite a switch into an if, and one task is to rewrite an if into a switch, which, as you can see, are really similar to the task that we've done so far. We turned an if-else cascade into a switch, and we tried to reason about what you can do with switches and ifs. In fact, try to apply the switch to the check login if you're able to. Try to do the same with calculator, which is exactly what we've done. And if you want, reason about how and if you can do this transformation from if-else to switch, also for the generation exercise. Can you turn this into a switch statement? Maybe yes, maybe not. Is it convenient? Is it not convenient? We will see. You will tell me next Wednesday or in chat on Discord. Okay. That's it for the switch. And before functions, since I completely skipped loops, we're going to have a look at loops. So switch is fine. We're going to have a look at loops. Are you ready? Woo! In the tutorial, the switch was actually explained right after the loops. But I wanted to show you the switch before the loop because, first of all, many of you asked me about a more convenient way to write things rather than just the if-else with all the that duplication of the variable. And also because I think that switch is more comparable to the if-else rather than the loop. The switch is just a fancy way to write an if-else. But probably javascript.info shows the switch after the loop because switch uses a keyword called break, which is available also in loops. So as you can see here in my slides, Loops are all about the while, the do while, a for, the break, and the continue. Okay, let's do loops. A loop looks a lot like an if, but repeated multiple times. So if you see the syntax is really similar to that of an if. In fact, you have a while the condition is true, and then some code which is usually called the body of the loop. And as you can see, the only difference between the while and the if is that you write while instead of if, and that's it. But there's a lot of differences, of course. For instance, there's no else in this case. The while condition, this while loop, is going to perform the same body over and over again until this condition is true. If the condition is true, I'm going to do the body. And at the end of the code body, I'm going to check again the condition. Is this condition still true? Yes, it is. So I'm going to continuously repeat the body until the condition becomes false. If the condition becomes false, then the body will not be executed anymore, and I'm out of the loop. So if you want to make a comparison, you can check. I don't know if you have kids. I don't yet. But when I was a kid, I usually went into trips with my family by car, and I used to say, "Hey, have we arrived yet?" No. And now, have we arrived yet? No. Have we arrived yet? No. And finally, have we arrived yet? Yes, we have arrived. Okay. That's it. So this is exactly what the while condition does. While loop does. I'm checking the condition over and over again until this condition is false. So we haven't arrived yet is true until we finally arrive. So that condition is false, and then I'm exiting of the loop. That's why there's no else in here. There's no reason to do an else. I'm going to execute this code while the condition is true. But at a certain point, the condition will probably be false, and then I'm just quitting the loop with no else. So a rookie mistake that I sometimes see is something like this. While condition, else do something. There's no else. If you want to do something when the condition is not true, you can, let's say something. If you want to perform something, if the condition is not true with a loop, you can just write something after the loop. Because while the condition is true, you are stuck in this loop body. But as soon as the condition is false, then you are out of this while loop, and it's going to execute that something that you wanted to execute at the end. So there's no reason to do an else in this while loop. How is it possible that the condition from true becomes false? Well, one way to do it is to use a comparison, for example, with a variable that changes its value. Like in this case, this is a common recipe. You declare a variable I equal to, for example, 0. And then you say, while I is less than 3, do something, but also change the value of I. For example, increment the value of I. This line here makes the loop a non-infinite loop. In fact, I++ means that the value of I will be incremented, so it's 0, but then it becomes 1, but then it becomes 2, and at a certain point I will become 3. And this condition, when I becomes 3, is not true anymore, because 3 is not less than 3. So I will end this loop, and no more alerts will be executed. Let's try this code here. Let I is equal to 0. While I is less than 3, I'm going to alert I and also increment I, which will have an effect on this condition, because at a certain point this condition will become false. Let's try. It's printing 0. Why? Because I was initialized with 0. I is less than 3, because 0 is less than 3, so it's going to alert it, and now the current value of I was incremented to 1. And if it's incremented to 1, I'm at the end of the loop body, so I'm going back to the while, and checking this condition again. I is now 1, and 1 is still less than 3. So I'm going to alert 1, and that's it. And then I is incremented again. So in the while, I'm checking 2. Is 2 less than 3? Yes. So I'm going to alert I again, which is 2. And then I incremented once more. I is now 3. I'm going to check again the value of I against 3. Is 3 less than 3? No. So I'm not going to run through this body, and I'm going to end it here. It's not going to print anything else. Now it's giving me 2 because this I++, as you know, returns the current value of I and then increments it. So if I check again the value of I will see that the value is now 3. Bobby says, wait, so what is the difference between the while and for loops? Not gonna tell you, because I didn't explain what a for is, but I'm going to do it in a while, so don't worry, or in a for. So yeah, I'm gonna tell you the difference between the while and the for, don't worry. So this is the while loop. It forces you to reason about what is happening step by step. And this is what makes it a little difficult. It's a condition that is checked multiple times and a body that is executed multiple times while the condition is true. But as soon as the condition is false, the body will not be executed and we are out of this loop. And this allows you, of course, to do things repeatedly. For example, if you have, an email client and you have multiple messages that you want to put in the spam folder, you can write a script that takes all the messages, and while you have messages in your folder, you're going to move the current message from the current folder to the spam folder. Move this, then move that, then move that, then move that, until you're out of messages to move. This is one of the applications of the while loop. You don't want to move the message 1 to the spam, then move the message 2 to the spam, then move message 3 to the spam. You just want to write a concise code that does it for you. Hey, take every message that you find in that folder and move them all into the spam folder. This results in code into something like, while my current folder is not empty, move the current message into the spam folder, and now the number of messages in my current folder decreased, for example. So I can do the while the number of messages in my folder is, 100, and then I decrease the number of messages until the number of messages in my folder is 0. And in that case, I'm not going to move any more messages anymore. So yeah, this is an increment, but you can also decrement, of course, and this is what you can see here. While let I is equal to 3. So now I'm starting from a high number, 3, not really high. And while I is greater than 0, or you can just say while alert I, and then decrease the number. So as you can see, the logic is really similar to the one before, but now we are decreasing instead of increasing. And this allows to write the formula, the condition, even more concise, because instead of saying I is greater than 0, I can just say I. In fact, I is a number, and I is a truthy value if its value is different from 0, and it's falsy if it's equal to 0. So that's why some people write this condition like this. And I can tell you, there's even people out there that say that this loop is more performant than this other loop, because the processor is faster when compared to 0 rather than when it compares to a number that is not 0. But I'm going to tell you, who cares about this? Who cares about performance? If you are used in your mind to count things from 0 to 5 instead of from 5 to 0, please use this form, which is much more readable to you and to any other human beings. We don't care about obtaining the peak performance. unless we are doing microcontrollers, low-level programming, game engines, or whatever. But in our case, we are high-level developers. We don't care about that kind of performance. We don't want to do premature optimization. Angelo, could we really write such a spam folder code in JavaScript that works on our computers, or is JavaScript only for stuff in the browser like HTML? Sorry for the shitty formulation. No, it was really clear. Yes, somehow you can do this kind of stuff in JavaScript. You can even do it in your application, desktop application. It would be strange actually, but you can. I have Mozilla Thunderbird as an email client on the desktop, and Mozilla Thunderbird allows me to select all messages and move all selected messages into the spam folder. Inside the code of Mozilla Thunderbird, there is a while loop that is going to get all the messages, and one by one it's going to move them in the spam folder. If I want to do it myself, I have to write some code that hacks on the desktop application Mozilla Thunderbird, which is probably not what I want to do. I don't even know how Thunderbird is created. What is the language? I think that it was written in Java, at least the interface, and maybe now it moved to JavaScript, but I'm not sure. I have no idea. So I still wouldn't do such a thing. But for example, I'm going to confess you one thing. I have an online bank account. My online bank account is able to show me the latest, 30 movements. And if I want the latest 30 transactions, but if I want to see more transactions, then I have to press a button and see the less recent 30 transactions and other 30 recent 30 transactions, etc. And then the interface of my online bank account is able to show me just until, 6 months, 6 months in the past. But I want to see the whole year. How can I do this? Well, I hacked a little bit on the code of my bank account, and I wrote a JavaScript script that is able to hack on my online bank account, provided my credentials. So not everyone is able to access my bank account, only me, because I know my credentials. But still, it's able to perform a call to the underlying server, to the underlying API, so that I'm able to overcome the limitations that are provided by the interface, and I can download the whole year of transactions. So yeah, you can hack on things. You can hack on things on the browser, and you can also hack on things on desktop applications sometimes. For example, I already showed you that Visual Studio Code is actually just a Chromium instance. If I do Control-Shift-I, nothing happens. But if I do developer tools, toggle developer tools, this is exactly the Chromium developer tools. So I can hack on my same desktop application in JavaScript. Other languages such as Java or C# do not have this kind of developer tools in which I can hack on my application. But still, if you have the source code, you can change that source code, recompile it, and do whatever you want. So yeah, there's many things that you can do with coding. You can automate things by writing scripts. But it's 12:01, so we're going to have a short coffee break, just 5 minutes, and then we're back to loops. Okay? Bye, see you later. A few moments later. Here I am again. I hope everything's fine for you. That's tough. This is tough matters, and we just scratched the surface. So please worry. But it's the 13 today. No, it's 30. No, it's not the 13. I don't know why I thought that today was the 13th of January, but it's the 30th. So there's no excuse. It's just really complex stuff, and I told you it's the boss. It's the main boss of our journey. So the loop is just like this. You usually this is the usual recipe. The general loop is just while a condition is true, do something. This is already a very, very common recipe that I encourage you to just learn by heart. You declare a variable with an initial value. You do some condition on that variable. And you also make sure that that variable changes somehow in the body of the loop, because if this variable doesn't change, this condition is probably going to be true forever. And the loop will be an infinite loop. So with this thing, you start to create your first virus, because with an infinite loop, your processor will waste its time to just do something completely useless over and over again. So you don't want to do that. You want the loop to end at a certain point. And that's why the condition should probably rely on some variable that changes its value inside of the body and makes the condition eventually false. This other loop is really, really similar, but it's a countdown. So it starts from a high value and it decreases until it becomes 0. And this is another really, really common recipe. Curly braces are optional, are not required. You can put the whole loop in just one line here. You start with a variable I equal to 3, and then while I is there, it's not 0, then you alert I and also decrease the value. How readable is this? Not readable at all. So please don't write code like this, which means that Bobby will write code exactly like this. I'm pretty sure about that. And also put the var instead of the let. I understood you. Then we've got other ways to do loops. One is less important. For example, this. This is the do-while loop. And I don't want to stress too much on this because it's pretty useless nowadays. The do-while loop has a similar syntax, but it's something like do something while some condition is true. So instead of let's change this. Well, something and then something else. Oh, else was actually seen as a keyword. So the while loop is while the condition is true, do something, and only once the condition is false, then I will do something else. The do while loop instead is something like do something while the condition is true, and then at the end of this loop do something else. The only difference here is that this body will be executed at least one time. So it executes the body and then checks the condition. If the condition is still true, then I will redo something. And if the condition is still true, I will redo that something again until the condition becomes false. Then I'm going to quit from this loop and then do something else. Instead, the while that we already know first checks for the condition, and then only if the condition is true does something. You could have whiles that have a condition that starts false. In this case, nothing will be executed and we will jump directly into this other path and then something else. So there's just one slight difference, which is do that body at least once in the do while. But we can prove pretty easily that every of the three kinds of loops that I'm going to tell you about, the while, the do while, and finally for Bobby, the for loop, are equivalent. You can write one in the form of the other and vice versa. But we don't really care about that. So we are going to use the while in general. We are never going to use the do while. Also because in my experience, and I have quite a year experience in JavaScript and in other programming languages, I never needed to use a do while. Also because you can convert the do while into a while. And since it's a less common way to do loops, it's probably more convenient to write whiles instead of do while, because some newbies could come into the do while and don't understand what it is. So let's not talk too much about the do while. We don't really care about that. But still, yeah, you can write the code in a similar way. Let I is equal to 0, then do alert I and I++ while I is less than 3. What happens here? I'm declaring a variable called I, which has a value of 0, and then I'm going to immediately alert I. So I will alert 0. Then I'm going to increase I, so I is 1, and finally I'm checking the condition. Is I still less than 3? Yes, it is, because I is 1 now. So the condition is true. I'm going to repeat the body again and again until I becomes 3. So in that case, the condition is false, and I'm going out of the loop. This is really similar from this other one here. The only difference is that I'll show you the difference. No? Okay, let's start with let I is equal to 3. What happens here? I is equal to 3. The condition is already false, so nothing is going to happen. I'm never going into the body of this while because the condition is false, so I'm just getting out of the body of the loop body, and that's the end of my code. Nothing happens. What if I write the do while? I'm going to write it by hand so it's more clear. Let I is equal to 3, and then do in curly braces. I'm going to alert I. I'm going to put those spaces that are put inside of the tutorial, and I++. And then I'm going to continue doing this while I is less than 3. What is it going to happen? It's going to alert at least one the 3. That's it. That's the only difference. It's going to execute the body before checking the condition, while the common while that we know first check the condition, and only if this condition is true will execute the body at least once. That's it for the do while, and now finally we can have a look at the for loop and what the difference is between the while and the for loop. I'm just checking if I see your comments. Everything is in place? Yeah. So what is the for loop? The for loop has a strange syntax, which I'm going to show you here. For, and then in parentheses, we've got 3 statements, not 1, not 2, but 3. And they are usually called, begin, semicolon, condition, semicolon, and then what it says here, step. And then in brackets, in curly braces, you can do something. This is the syntax of the for loop. The for loop is exactly like a while loop, but it makes things more concise. That's it. You can turn a for loop into a while, and vice versa. You can turn any while into a for loop. You can turn a for loop into a do while, and you can turn a do while into a for loop, and vice versa, and every possible combinations. Let's see an example. I already told you that a common recipe is let I is equal to 0, and while I is less than 3, then I'm going to alert, for example, the value of I, and then I need to increment I, otherwise I'm never getting out of the loop. Well, in this recipe, we can locate 4 different important statements. This one is the declaration of a variable and the assignment of an initial value. This is the begin that you find in the for loop. This is the beginning of our loop. This, I less than 3, is a condition that we have to evaluate. This thing here, this increment, is the step, because we are stepping one step forward in order to make the condition not true anymore at a certain point. And finally, this is the something, we can call it the body. Just call it the body of the for loop. So as you can see, the while loop, this recipe that we now learned, has everything we need in 4, let's say 5, including the closing curly brace, 5 different lines. We've got the begin, we've got testing of the condition, we've got a body to be executed, and at the end, usually we put it at the end, we put the step to move forward. Now, if you want to create exactly this recipe in a for loop, you do for, and in parentheses, you put begin, condition, and step all together in the same line, separated by a semicolon. So, first of all, the begin, and I can even put it like this, let I is equal to 0. And semicolon. Semicolon separates the different statements. So I could put them one in a different line, each one in a different line, but the for loop makes it really convenient to put these 3 statements in the same line separated by semicolons. So semicolons are usually optional, but this is one case in which it's really convenient to use semicolons to separate these 3 statements. So this is the begin, then we've got to put the condition, and the condition is I less than 3, semicolon, and then the step. The step is I++. And then in curly braces, we just put the body. So alert I. That's it. This is the form of a for loop. And it's exactly the same as the while loop, but I think it's a little better sometimes than the while loop, because the while loop mixes everything together and separates everything into multiple lines. But in here, we are separating the loop logic, which is about beginning, checking a condition, and incrementing the value. And we are separating it completely from the body of the loop, which is not mixed with the step like in the while. So if you want to do a loop over a number that is increasing, then probably this for loop is a little more readable and also more concise than the while loop. But they are totally equivalent, exactly the same. So to recap, this is the while loop generic form. While condition, do something, which is the body. And when the condition is false, I will not do something anymore, but I can do something else after the while. This is the do while loop in its generic form, which is really similar to the while loop, except that the body is executed at least once, because it's executed before checking for a condition. I hope that I'm not missing your messages, because I inadvertently reset my application on my mobile phone. And then we've got the for loop generic form. I didn't put form here. Which puts the begin, the condition, and the step statements all in the same line inside of the for's parentheses. And then the body is somewhere else. Is actually just the body of the for loop. So this is how you do a loop with a while, common recipe. This is the common recipe of a for loop that checks for a variable, declares a variable, checks if the variable meets some requirements, increases the variable so this condition will eventually become false. If it never becomes false, it will loop forever. Let's go forward on this. Blah, 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 blah. Yeah, this is a breakdown of what happens in a for loop. So in a for loop like for let I is equal to 0, I less than 3, I++, alert I, what happens is that you declare I with a value of 0. Then you check a condition. If I is less than 3, then I'm going to alert I and then also run the step. If the condition is still met, then I'm going to alert I and then run the step. If the condition is still okay, and then I'm going to alert I and then run the step. But then I finish because I is 3, the condition is false, and that's it. So as you can see, the for loop allows you to write in a more concise and also generic way, something that you would have to repeat over and over by yourself, which is not what you want to do. If I want to count all the numbers from 1 to 100, I don't want to write 100 lines of code that allow me to do this counting. Instead, I can create a loop like for let I is equal to 0, I is less than 100, I plus plus, and I'm going to console log this time the number I. It is much better to put those in new lines. I want to make it much more readable. And then there it is. I've got every single number from I wrote it wrong, sorry. I'm gonna do it again, sorry. Let equals 0 has no meaning. Let I is equal to 0. So from 0 to 100, bam, I've got all the numbers from 0 to 99 actually, because I should be less than 100, but I've got them all immediately without needing to print them all one by one. So it's really convenient, especially for big numbers. What if I want all the numbers from 1 to 100 instead of from 0 to 99? Well, in that case, you just need to juggle a little bit with these statements that you already know. So let I is equal to 0. I don't want to start with 0. I want to start with 1. Okay, let I is equal to 1. And I want to print the number 100 included, not excluded. I don't want to stop at 99. I want to stop at 100. Okay, so I'm going to say less than or equals 100 or less than 101. And in this case, I'm going to print every number including 100. Let's try out. And there we go. We've got every number from 1 because the begin statement now starts from 1 and not from 0. And we stop at 100 included this time. So the recipe is there, but then you can change it however you want. Do you want to print all the even numbers from 1 to 100? That's fine. You can start from 2 because 1 is not even and you don't want to print it. And you can step by using more explicit increments. If I do I plus equals to 2, you remember what that means? It means that I will be incremented as itself plus another 2. Just like I plus plus means I plus equals 1, which also means I is equal to itself plus 1. So if I just say I is equal to I plus 2, or in the shorter form, I plus equals 2, I'm going to increment I by 2. So I'm starting from 2, and then I'll get 4, and then 6, and then 8, and then 10, without skipping all the odd numbers. So right now, I is equal to 2. I starts from 2. I will stop only when this condition will be false, so when I will be greater than 100. And in the meantime, I'm going to increment by 2. What does this do? Here it is. All the even numbers from 2 to 100. As you can see, there's no odd number here. Okay, so this is the maybe tricky part. The for loop is just syntax. But then what you can do with the for loop is a whole world of things. And you have to try them one by one because it's really, really important to understand, based on these simple rules, how many things you can do. You can declare this variable inline, as we did, or you can declare it somewhere else. You can declare the variable let I, and then here you assign a value. You can do it. You can use an existing variable. This is a common way to do it. But if I want to declare a variable here, I can do it. Why should I want to do this? Well, maybe because I want to get this number from the user. Prompt. Blah, 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 blah. Okay? So I can do as many things that I want. The code is there. The rules are there. You can just play around with them and find different ways to use them. You can even prompt here. This is ugly, but you can. You can prompt the user here. Give me a starting number. This is awful. I wouldn't do it, but still, you can. I'm just showing you what you can do with a for loop. So for let I is equal to prompting the user, converting it to a number, and then continue the loop like this. Give me a starting number. I'm going to say 2. So it's printing 2, and then it's over, because after 2, I incremented and became 3. So this statement, this condition is false, and it didn't alert anything anymore. So as you can see, I even asked for the user where to start, and I could do exactly the same probably in here. But in this case, something strange happens. And this is another way you can play around with things. So give me an end. What do you think will happen right now? Do you think it's going to ask me for a starting number, ask me for an end, and then loop? This is not exactly what is going to happen probably. Let's see. Give me a starting number, 2. Give me an end. I will say 5. It says 2, but now it still says give me an end. Again, I will say 4 this time, 3. And again, give me an end. Oh my God, okay, 4 again. And it stopped. What happened here? Well, the rules are there, so you don't need to learn anything by heart right now. You just have to reason about what is happening. And what is happening is that, as you know, the begin statement is executed just once. It's just the initialization of the variable. But the condition is executed at the end of every loop. This condition is executed multiple times until the condition is false. And the same goes with the step, and the same goes with the body. The only thing that is never executed multiple times, and it's executed only once, is the begin statement, because this is the initialization of the variable. But the condition is executed multiple times, and this is exactly what is happening here. So I was prompted just once. I only saw give me a starting number once. But then I saw multiple times give me an end, because every time the loops starts over, I'm being asked to give an end. If I don't want to be asked this end multiple times, I have to write my code in a different way. I'm going to copy it here. How can I just ask the user once for an end? Well, pretty easy. I can declare a variable, let end, and I'm going to store whatever the question was here. And I'm going to use this variable here. So this way, I'm asking the user which is the end. I'm going to put also the semicolon. And then I'm going to use whatever variable I got from the user, even multiple times here. And you know what? It's probably even better to do the same with the start. So we can do let start is equal to plus prompt. Not because it's important, but this makes the code a little more readable. I'm asking the user to give me the start and the end, and then I'm going to use those variables in a standard for loop that starts not from a number, but from whatever value is stored in this variable, and it's going to be checked against another variable which stores the value that was asked for from the user before. So as you can see, I'm always separating the input from the user or declaring special variables, results of calculations from the rest of the code, which is more convenient because it makes the code more readable, it makes the code less error prone. We fixed a problem that was asking the user multiple times for an end, which was stupid. And in this case, instead, we're going to ask the user for a starting number, 2, for an end number, 5, and then the user will be not bothered anymore by prompts. It will just be alerted multiple times, from 2 to 5. So it will give me 2, because I started with I equal to 2, and it's going to be alerted. But then 2 becomes 3. Is 3 less than 5? Yes, it is. So it's going to print 3. Now I becomes 4. Is 4 less than 5? Yes, so it's going to be printed. But then I is incremented once more. It becomes 5. 5 is not less than 5, so I'm out of the loop. This is how loops work. Pretty easy, but also pretty complicated because there's so many ways you can use loops. For example, skipping parts. You can even skip some of the statements. For example, if you have declared and assigned the variable, if you have the begin already there outside of the for, you can completely omit the begin inside of the for, provided that you still add this extra semicolon, because this semicolon allows JavaScript to understand that here we should have a begin, and this is the condition, and this is the increment. Let's look at this code here. If I don't put this semicolon, it looks like this, since it's the first statement that I see in the for, it looks like this should be the begin. But this is not the begin, this is the condition. That's why we need to put this extra semicolon to say that here there's nothing. The begin is nothing, because the begin was already written somewhere else, which is on this line here. And then we've got the condition and the increment. You can even remove the step if you want to. Please don't. But still, if you want, you can do the step inside of the body, which makes no sense at all. In fact, this is really similar to the while loop that we saw before, and it's even a mixture of alerting a number and also incrementing it at the same time in the same line, which is really ugly. So please don't do this. But in theory, you can. You can just put the condition here. And what if you don't put anything at all? You don't put a begin, you don't put a condition, you don't put a step. For with just a couple of semicolons. You see how it looks like it's crying? Well, it's crying because this is an infinite for loop. It doesn't begin with anything. It doesn't test for any condition. It doesn't increment anything. So this is a for loop that is going to go for eternity until you just block it. So for semicolon, semicolon, console log infinity. What is going to happen here? Yay! Infinity is increasing and increasing until my computer explodes, probably. No, it's not going to explode, but it's going to consume a lot of RAM. In fact, this tab has already frozen, and I hope it didn't freeze my stream. Are you still there? Please tell me anything. Yes, okay, cool. So I blocked the infinite for loop on time, awesome. And can you do an infinite loop on with a while? Yes, you can. So an infinite loop with a for is something like this. And then you just console log whatever you want. Infinite loop. And if you want to do an infinite loop with a while loop, pretty easy. The statement is something like this, while console log whatever. And you just need to put a truthy value inside of the condition, which can be, for example, true. While true, console log infinite loop. Or as the C developers like to put it, while 1, which is a truthy value, console log infinite loop. C developers use the value 1 because in the C language, which is pretty ancient, there were no concept of Boolean values. So we had to use ones and zeros. But since we have Boolean values, we can say while true. This is an infinite loop. Is an infinite loop useful? Sometimes. Sometimes you can use infinite loops decently. For example, in a video game. Well, a video game usually has an execution loop. So every 60th of a second, the game is going to step forward. The game is going to gather input from the user, is going to perform some calculations, for example, on the physics, on collisions, on gravity, and then it's going to render the scene, the current scene. And then the loop is starting all over again, asking for, listening for user input, performing calculations, rendering the scenes. And this goes on over and over again. But usually that's not infinite. Usually you can stop a game. You can stop a game, for example, by pressing, I don't know, Alt F4, which means close the application, or going to the menu and saying quit the game, quit to the main menu. So this is a good application for a while loop. So you can say something like, let's, I don't know, is playing is a Boolean variable which is true. Let is playing is equal to true. Then while is playing, then you can do whatever you want, but you can also prompt the user for an answer. For example, prompt the user for, do you still want to play? And if the answer is yes, or it is true, or whatever you want, then I'm still continuing playing. But if the answer is no, I don't want to play anymore, then I can change the value of is playing into false, and I'm going to not play anymore. If I'm not playing anymore, I'm going to alert by. Oh, this is bad. I have to put it here. Okay, I'm going to alert by only if the game is over. You know what? Heck, I think that this is better. Is game over? Or just game over? Game over is false. And while it's not game over, not game over. Oh, now it froze for me. Okay. Does anybody experience a freeze? I'm gonna close the Chrome. No? Okay. So everything fine here. So Angelo, I'm sorry, but I think that you have connection problems this time. Please tell me if you still experiencing trouble. Okay, fine again after reloading. Sorry. No worries, no worries. Thanks for telling me. I don't want you to miss anything. So I'm going to say let game over is false. Game over is a Boolean variable that tells me if the game is over. And so far, it's not over. And while it's not over, I'm going to ask the user, do you still want to play? If the user tells me that they don't want to play anymore, then game over will be true. And then I'm jumping outside of the loop and saying bye. So here I can use a switch. I'm going to switch on the value of the answer. And if the answer is no, then I'm going to say that game over is true. And I break. By default, I don't really need to do anything, but I can use a default case. For example, by default, if the game is not over, I'm going to alert something. Something like still playing. I don't know, something like that. So let's read again this code. Let game over is false. We start with a Boolean value that is false. While the game is not over, I'm going to continue doing this stuff in here, this body. I'm going to ask the user if the user still wants to play. And then I'm going to switch on the answer. I could do this with an if else. I could do this with a ternary operator. It's exactly the same thing. Let's do the switch since it's a new concept and we haven't done any practice on this. I'm switching on the answer. If the case is no, then I'm going to change the value of game over from false to true. And I break the switch, which means that I'm not going forward here. The body of the loop is over and I'm going back again, evaluating this condition. The condition is now false because not game over means not true. And not true means false, which means that I'm out of the loop and it says bye. I don't know if it's too complicated here. Maybe game over makes it more difficult. We can create a variable that has exactly the opposite meaning like we did before. For example, is still playing is true. While is still playing, do the blah, 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 and then is still playing is false. It depends on your taste. If you're fine with the concept of game over, then this is good. Otherwise, we can turn it around. Let's see what happens with this code. I'm going to copy it and put it in our browser. Do you still want to play? Yes. Still playing. Do you still want to play? Yes again. Still playing. Do you still want to play? Yeah. Still playing. Do you still want to play? No. Bye. And that's it. So as you can see, mine was an infinite loop, but now it's not an infinite loop anymore. It's a loop that will go on and on and on until I change the value of the game over variable. I think this example is really, really important because usually when you look at tutorials, they always show you loops that use numbers, but especially with the while, the number is not that relevant. You just need a variable that starts with a value, and then inside of the loop you have to have the ability to change the value of that variable, even if it's a boolean or a string. What can we do to improve this code? Well, the user could say no, or the user could also input a no with a capital N, or all capital, or nope, or no way, or something like that. And we can group all these cases like this. I hate how the switch is indented automatically. You see, I'm adding more and more cases. And all these cases are just an or between this answer and all the possible values. If the answer is no, or no with a capital N, or no all uppercase, or nope, or no way, then game over will be true. In any other case, I'm still going to see still playing. Hope this makes sense. Really, really tough. That's why I really, really, really encourage you to do exercises and practice a lot on this stuff. It's really tough. Oh, now I remember what the 13 is about. This is lesson number 13. So that's why it's an unlucky lesson. Okay, so this was a for loop. Let's see if we have other things that we can see. Yes, we can. But first, can I change this while into a for loop? Yes, I can. Probably I shouldn't. But for the sake of the exercise, we can try switching, turning this while loop into a for. We just need to locate what the different scenarios, we have here. And it's probably quite complicated here. Let's find out. So this looks like a begin in the for loop. This here looks like the condition in the for loop. This game over is equal to true looks a bit like the step. It's not really a step, but it's what makes the condition become false at a certain point. So it's not really a step. In the for loop, we usually see the step as something that increases and increases and increasing until the condition is false. But with Booleans, we don't have this kind of thing. We just have a variable that stays false until it becomes true. So there's no real step. And also, the problematic thing here is that the step is conditional. The step is going to change the value only if something happens inside of the loop, which is not the case of the for that we saw so far. The case of the for that we saw so far just increments every single time at the end of the loop. But in this case, we are changing the step only if a certain condition applies. So turning this while into a for loop is actually a little complicated. We can try. For. In the for, we add the begin, we add the condition, and we add the step, and then we add some body. This is what we have to do. So the begin, we already located it. It's the game over false variable. So I'm going to, statement, sorry. So I'm going to put it here. The condition is this one. It's not something less than something else or something is greater than something else. It's just, it's not over. Okay? The condition is any Boolean condition. And the condition can also be not numeric at all. It can be while the game is not over, like in this case. Then we've got some body, and the body should be something like this one. So I'm going to put it here. But now, still, we've got a step that we really don't know how to put here. And because the step changes only in certain scenarios. So how do I put this step in here? Well, the answer, if you don't want to try it yourself, you know what? I'm going to drink a sip of water so you can think of an answer in the meantime. Please bear in mind that usually when I ask you questions, I'm sorry for that, but they are usually tricky questions. And this is no exception. This is a tricky question. I would say it's a bastard question, not tricky one. How do I move the step from the body to here, knowing that this step should not be just executed anytime? It's not like this, because otherwise, at the end of the first loop, game over will immediately become true. So this is not what I want. I want the step to still be conditional. So it must change only if one of these cases is true. So I don't want to just put game over is equal to true in here. And I think it's not even convenient to put all the switch case inside of here, because it's pretty ugly and probably even not correct from a syntactic point of view. So the answer to the riddle, how do I move the step from here to here, is, drum roll, I'm not doing it. I told you that was a bastard question. I'm not doing it because the for loop, as we already said, can populate all three statements, the begin, the condition, and the step, or it allows you to not do it. And what is the reason to not do it? Well, this is one of the reasons. If the step should be calculated somehow inside of the body, you don't put it here. You just leave it in the body as a result of a calculation. So the question now is, well, do I really need a for loop in this case? Probably not. When I'm looping over numbers, then the for loop is quite cute. I like seeing this let I is equal to start, I less than end, I plus plus. It's a standard form, and whenever I see it, I feel at home. But whenever I'm not using numbers and I'm using Boolean values, Boolean statements, it's really strange to see a for loop used in this case. It's so much easier to read it as a while. Let game over is false. While it's not a game over, I'm going to perform calculations, and that's it. The while loop looks a lot more readable in this case, I think. Not sure if you agree with me. Probably Bobby doesn't agree with me because he's a rebel, and I like that. So if you don't agree with me, please do your experiments and try to come up with your own conclusions. Don't trust me. Just trust your guts. And remember to question everything, including and especially yourselves. Question me, question the material that you find online, question Google, since they recently did something quite bad, and question yourself especially. Okay, what else? We can break the loop, which is something that I usually not recommend at all. In fact, inside of a loop, a while, a do while, or even a for, you can use this keyword that you already know. It's break. Break interrupts the loop abruptly. So look at this code. Let sum is equal to 0. While true, so we have an infinite loop. I'm prompting the user for a number. Sorry to interrupt. Were you talking about the stocks? Yes, I was talking about the stocks. Probably it's too political as a subject, so I shouldn't have said it. But yeah, I was talking about the stocks. Google removed all the negative reviews from the Robinhood app, which is not really democratic. They already did it once with TikTok, as far as I know. And now they did it with the Robinhood app. I agree with you. Okay. So let value, I'm asking the user for a numeric value. I'm also, as you can see, converting the string into a number immediately. And then if I don't have a value, which means that if the value is undefined, null, not a number, 0, if the value is not a valid value, and it's falsy, then I'm going to break the loop. So this looks like an infinite loop, but it's not. It's an infinite loop until I break it. And if I don't break the loop, then I'm going to continue. So if the value was actually a valid value, then I can increase the sum with this value. And at the end of the loop, I'm going to alert the sum. So this is a pretty cool application. We can inspect it a little more. So let sum is equal to 0. While true, I'm going to ask the user for a value. Now here we've got an if that doesn't even use the curly braces, but I love curly braces. They make the code so much more clear. And then we've got this sum plus equals value. Now reading this code is a little trickier because you have things that are jumping inside and outside of the loop. It looks like you ask for a value, you do an if, and then you always do a sum plus equals value. But this break here is preventing you from going forward and performing this calculation. Instead, it's jumping outside of the while loop. It's going to completely interrupt the while loop and it's jumping into the alerts. Let's try it. Let sum is equal to 0, while true, blah, blah, blah. We know it already. So enter a number. I will say 3. Enter a number. Let's say 4. I'm bored. Enter a number. Nah. Sum is equal to 7. So here we've got a lot of stuff. Let sum is equal to 0. This is a variable that has nothing to do with the begin condition step. This is not part of the loop. This is just a variable that starts from 0 and it is being accumulated, incremented, because we want to calculate a sum of different numbers. So this is quite a useful recipe because when you want to sum two variables, you already know how to do this. You can do let num is equal to prompt the user. I'm not going to write everything, but you know the gist. Let num is equal to prompt the user. Let num2 is equal to prompt the user. But every time you want to add other numbers, you have to write another number here and another one and another one. And what if you want to add multiple numbers together, 100 numbers together, or whatever amount of numbers the user wants to add? Well, in that case, adding all this let num1, let num2, let num3 is not really that convenient. You want to make it more generic. You want to process all this in a loop. So this code is actually pretty cool because it looks like our calculator. We can initialize the final results. The sum can be seen as the results that we have in the calculator. This calculator just does the sum, as you can see, and we don't care about any other operations, at least for now. And inside of an infinite loop, which is not actually infinite, we're asking for a new number. So this is num1, num2, num3, the more we go forward in the loop. It's just called a generic value. And the value will be accumulated in the result. And at the end of the loop, I will get the result. This will go on forever until I decide that I don't want to add values anymore. And how do I decide it? Well, the condition that was written here is that the value should be something different from 0, null, undefined, a non-number, like the what did I write before? I said nah. Okay, nah is a string, and when you convert it to a number, it's not a number. So this breaks the loop. The sum was 0. I got inside of the while, it got me, I did the prompt, but the value was already not a valid value. So I didn't even increase the value, and I jumped outside of the while, alerting the final result, which is actually the same as the initial result. The sum is 0. So nothing really happened here. So as you can see, this is a really interesting application of a loop. An infinite loop that is broke with the break statements. Why am I not fond of the break statement? Because the break statement makes the code less readable. It looks like an infinite loop until you see that somewhere in your code there is a break. This is not really that readable. And that's why, for example, in my case, I didn't use the break. I didn't have to use the break. Well, I used the break inside of the switch case because the switch case is done like this. You have to put breaks inside of the switch case. But if you don't look at the break inside of the switch, I didn't break the loop. I just made the condition false, which is what you should always do too. So if you want to rewrite this code without using break, you can. And you can say something like this: let result is equal to 0, as always. And then you can declare another variable, like the current value. The current value, I don't know what is the current value. Let's say that the current value is, I don't know, 3 for some reason. Now, while the current value is different from 0, I'm going to assign a new value with a prompt. So I'm just replacing whatever value I put here with a prompt. Enter a number with a default of empty string. Why not? So as you can see, I'm using an extra variable that has a completely random value so far, and then I'm checking if the value is different from 0, which is exactly the opposite of this. If the value is 0 or not a number, I will break. But here, my condition is the condition to continue the loop, not to break it, while the value is not 0, or I can say, while we have a value, I'm using the truthiness of this number to make the condition more concise. So the value is something, and I can just accumulate the result with the current value, unless the value is a falsy one. So I'm putting again this if not value, and instead of breaking, I'm going to, you know what, I'm going to say this. If we have a value, then I'm going to increment it in the results. Otherwise, I'm not going to do anything, because if the value is falsy, I'm not going to do the increment. The loop has the body of the loop has ended, so I'm going back at the start of the loop. The value is now not a number or a 0 or whatever, and it's not going any further. So I think that this code is pretty equivalent to what we have here. Let's find out. I'm going to try it. Let result is equal to 0. Let value starts with a random value, which is 3. Then while we have a value, and the 3 is there, because if I start with 0 or with undefined, then this condition is already false, and it's not going to do anything at all. So I'm going to start with 3, just to make the condition work at first. And then I'm going to check the value from the user, and if the value is actually a valid value, then I'm going to increase the value. Otherwise, there's no else to write. If the value is a 0 or still a not valid value, the if is not going to be performed. The value is 0, this condition is false, I'm getting out. I also need to do an alert, otherwise this code does nothing at all. So doing this, let's see, enter a number. I'm entering 3. Okay, enter a number. 4, okay. Enter a number. Nope. Sum is still equal to 7. So this code is pretty much the same as the code with the break statement inside. But apart from this, which is a WTF moment, This code is probably a little more readable than this one here, because breaking a cycle abruptly, especially an infinite cycle, is pretty strange. But here we don't have an infinite value. Here we have a loop that is under control. This loop will go on until this condition is true. And the condition at a certain point, well, rather implicitly becomes false. So probably this is a little more readable. The only part that is not really that readable is this value is equal to 3. Why is 3? Why is it not 5 or -1 or pi or whatever? Well, I think that this is a problem. This is one of those code smells that we can probably try to change. And how can we change this? Well, for example, instead of just giving a random number like 3, we can probably prompt the user immediately. At least once. I'm asking the user for a value. If there is a value, then I'm not going to ask the user again immediately. I'm first checking for the value and incrementing, like this. And then I'm going to ask again the user with another prompt. I don't like this code because it's duplicating a line of code. I'm declaring a variable and assigning an initial value by prompting the user. And then on line 121, I'm doing exactly the same thing. I'm asking again, what's the new value of the user? But still, this code has the same meaning and it removed that WTF moments there. That's a strange number that had no meaning whatsoever. Enter number 3, enter number 4, enter number, sum 7. It works exactly the same, but written in a slightly different way. Another way we can write this code is with the infamous do while. Because the do while was born for this kind of reason. Because we can immediately ask for a value to the user as the first thing, and then we can continue to do this again and again and again. So here we can say, wait a second, Angelo says, why is the break inside the if condition and not outside of it, as it belongs to the while loop? Okay, yeah, I really hope that it didn't generate confusion, but probably it did. This break here, is this break here? No, you said this if here, this break here. So why the break inside the if condition and not outside of it? Because sometimes you want to execute code only if a certain condition applies. So if I put the break outside, if I put the break outside like this, the meaning of this is while true. So I will loop indefinitely. I'm asking a value from the user. If the value is not valid, I'm not actually doing anything. And then whatever happens, I break. Which means that I'm outside of the loop right after I ask the value from the user and without performing any calculations. Whatever even valid value I ask the user, for example 3, it's still going to break the loop and going forward. So I want to put the break inside of the if because I want the loop to break only if a certain condition applies. So if the value is not a valid one or if it's a 0. That's why the break, even if is part of the loop, can be placed inside of an if. You can place it wherever you want, actually. Docker ignore. Hi, that's a new user. You should change spaces to 2 on VS Code, which located on footer Inglorious coders. Yeah, you're right. Here you see spaces is 4, and sometimes we prefer to use 4 spaces to indent code. Sometimes we prefer 2 spaces. There are multiple people that prefer 4 spaces because they make the indentation more clear. I personally prefer the 2 spaces because I don't care about my code being so horizontally wide. I prefer to have it a little less wide. And as you can see, the code that we wrote so far is a mixture of both. Here we've got 4 spaces. You see, every tab is 4 spaces. And here I've got code that is 2 spaces wide. This is a decision to make when you write code, and it's a decision that you have to share with other developers that are working on the same team. If you prefer 4 spaces, please share this convention with others. If you prefer 2 spaces, then please share this convention with others. Docker Ignore says, I only use 4 for Python, but I didn't know that people use 4 for JS too. Yeah, people can use also 4. In JavaScript, it's even less important because in Python, indentation is part of the syntax. In JavaScript, you can indent as much as you want. It just makes the code less readable. So yeah, much better to decide once and for all how many spaces you want for indenting. And my preferred way is 2 spaces. If you guys prefer 4 spaces because it makes more clear what the hierarchy of the statements is, please go to 4 spaces. Thank you, Dr. Ignore. Glad to see you here and glad to see you are interacting with us. So yeah, I should probably decide if I want 2 or 4 spaces, but don't worry because soon we're going to install and use this other tool that you see here on the footer, which is called Prettier, and Prettier makes your code prettier. So it automatically indents all of your code and makes it look good. But I don't want to do it right now because I want to force you guys to write good code with good indentation and not rely on some other tool that is going to spoil you. So we were talking about this code, which is kind of ugly because we are repeating the same sentence here. We've got this plus prompt and also another plus prompt here. Why do we need this? Well, as we saw, it's because first we needed to add a strange value like 3 in order to make the while look the while condition to be true and start the loop. But then 3 is not a special number, it's a completely random number, and having random things in our code makes the code less predictable. You also promised us a debugger. Yeah, that's true. You know what? We can start right today to use a debugger, okay? If you're fine with it, yeah, we can do some debugging. In fact, I don't have much to say about loops today. And I don't want to go forward with other concepts because this is a really huge concept. So we're going to use a debugger today for this last hour. So this code that prompts the user and then checks the value and then prompts the user again can be replaced with a do while statement. In fact, this is exactly what the do while is supposed to do. You first execute something and then you check. And in this case, we can do something like, I'm really not sure actually, let value, then I do value is equal to the result of prompting. Yeah, I'm probably right. And I'm prompting the user to enter a number. And then I'm going to increment the value, the result with the value. So I need also a let results as always. And I'm going to increment this value only if the value is a valid one. Like this. And then once I at least did this thing once, I want to check if the value is still valid. It's still a valid one. So I'm going to say while value. This do while loop, I saw you Docker Ignore. I'm going to reply in a while. Sorry for the puns. This should probably work. I'm not 100% sure, but it makes sense to me. Let result is equal to 0. I'm initializing a variable to 0. And then I'm declaring a variable, and I'm declaring it outside of here because I need this value inside of the do, but also inside of the while. And in order to make it visible to the while, I have to have it declared outside of the body, because every variable that you put inside of curly braces will be local to that block. So I have to make it stand out. So I'm going to initialize the value with a prompt. I'm going to check if the value is a valid one. In that case, I'm going to increment the result. And then I'm going to check if the value is a valid one so I can go over again and again on the loop. So let's try. Enter number 3. Yep. Enter number 4. Yep. Enter number... No. And I forgot to say alert sum. So let's just have a look at the result. It is 7. So the only thing that I was missing is the final alert. I always miss it. But still, this do while apparently is exactly the same as writing this while here. but it's a little more concise. It has less repetition. So that's one of the cases in which you could prefer to use a do while. But as I already told you, I usually don't see a do while in code, in production code. And probably because it's just a fancy way to do the same stuff. So yeah, probably I would never use a do while nonetheless. Docker ignore says, I don't know why, but we can able to initialize same variable again and again in Chrome DevTools. Example, x is equal to 3, let x is equal to 4, which is not possible on JavaScript. Yeah, that is completely true. And in fact, I'm relying on this strange quirk, but you are completely true. So I can say let number is equal to 1, and then let number is equal to 2, which shouldn't be possible because when you declare a variable, you cannot redeclare it. You can just assign a new value to that variable. But the reason is that I think that Chrome Developer Tools reason in a slightly different way. The Chrome Developer Tools think that this line of code is a whole block of code that has nothing to do with the rest. So, for example, if I say let number is equal to 1, and then with a shift enter, I go to a new line, but I'm not executing the statement, and I say let number is equal to 2, then these two statements are part of the same block of code, and probably in that case it's going to give me an error. Yeah, it's doing it. Instead, if I do let number is equal to 1, and then on another completely different execution, I'm saying let number is equal to 2, it looks like it's separating blocks of code into their own pair of curly braces. Wow, I didn't know that. Happy that I was useful. Actually, I was just experimenting, but apparently it's working like this, so I was lucky. What happens in Node? We didn't see Node for a while. Let's have a look at Node. In Node, if I do let number is equal to 1, and then let number is equal to 2, it's going to tell me that there's a problem. So as you can see, the REPL, the environment that we have in Node is not exactly the same that we have on Chrome for some reason. I think this is probably more correct. You cannot declare the same variable even in multiple executions. But in Chrome, apparently, it's slightly different. Probably because in Chrome, they want to give you the ability to copy and paste bits of code without overlapping with other code that you copied and pasted before. So probably that's the reason why Chrome is allowing you to do this and Node is not. In Node, you usually don't copy and paste code in here. You just execute some scripts. Okay, so finally we saw a little bit of do while, but this is not the only way to break the loop. There's also another strange, really strange keyword that is continue, which is actually allowing you to continue the loop. So let's look at this code. For let I is equal to 0, I is less than 10, I plus plus. This is the usual for loop that starts with a variable I from 0. It increases the variable until the variable becomes equal to 10, and in that case the condition is false and we end the loop. But inside of this for, we have a condition. If I%2 is equal to 0, I don't remember if we inspected a lot this thing here, but I%2, this is the remainder operator, and the remainder operator gives you the remainder of a division. So if you divide I by 2, it will give you some number with a remainder of, and this is what the remainder does. So for example, if you have 9 divided by 2 is 4, because 2 times 4 is 8, with a remainder of 1. So 9 divided by 2 is 4 with a remainder of 1. And this remainder operator is giving you 1. While if I divide 8 by 2, 8 divided by 2 is exactly 4 with a remainder of 0. So the remainder operator is really convenient to check, for example, if a value is even or odd. Because if it's even, the remainder will be 0. And if it's 1, then if it's odd, then the remainder will be different from 0. It will be 1. So this is a way to tell if a variable is even or odd. And if it's even, in that case the remainder is 0, I want to continue, which means that it will skip the remaining part of the body and will just go at the top of the loop. So this is a way to not break the loop, but break the execution of the body inside of the loop. So it's not going to alert the even numbers, and it's just going to alert the odd numbers. This is so strange that it's one of those keywords that I really, really encourage you to learn, because you have to know that they exist, and then never use them anywhere in your code. In fact, any of these keywords can still be replaced by something that is not that unreadable. Let's have a look at this code. For let I is equal to 0, I less than 10, I plus plus. If this remainder bugs you, we can separate the logic into another variable. For example, let is even is a variable which stores the results of saying I%2 is equal to 0. And then you can use an is even, whatever the value is, in here, which makes it a little more readable. Here we are calculating if I is an even number, and if it's even, then continue. So it means that it's not going to alert. Otherwise, if it's odd, because it's not even, then it's going to alert and then start again with the loop. Do we really need the continue? Of course not. We don't need this continue. If I don't want to alert if the number is even, I can just swap this value. If it's not even, then alert. Ooh, this is not what I wanted. Sorry, I'm messing around with my keys. Okay, this is exactly the same thing. If the value is not even, then I'm going to alert. And if the value is even, well, I'm at the end of the loop, so I can just go on the top and start all over with a new value for the variable I. So there's no real reason to use the continue keyword. And please don't use it, because it makes the code so much less readable than explicitly stating what you want. So don't use break and don't use continue. It's not worth it. And if you do an interview, well, you can find people that are fond of continues and breaks, but I think that for the majority of people, continue or break are evil and you should never use them. So please try to use standard ways, standard conventions that make your code much more readable. And look at that. The continue directive helps decrease nesting, and this is really, really similar to what we wrote. The only difference is that they say I%2 instead of I%2 different from 0, because I%2, if it's an odd number, it will give you a value which is different from 0, so this is a truthy value, and in that case I will be alerting. So the continue directive helps decrease nesting. If you use an if, you can see that the alert is nested inside this if. What they don't show you is that with the continue, you still have nesting. In fact, I'm going to copy and paste this code again. There is a nesting here. The continue is nested. The only thing that is not nested is this alert. But my question now is, why should you care about not nesting the alert? In fact, you want to make it clear that alert will be executed only if a certain condition applies. And here it's not really clear. It looks like the alert will be performed every time, and it's not true. Well, this code shows exactly what's going on. Alert will be executed only if the condition is true. So I want this nesting to happen. We don't care about removing nesting. No break continue to the right side of the question mark. So, okay, you cannot use continue and break in ternary operators. Who cares? Labels for break and continues. What is that? I have no idea what this is. Okay, so what they are saying here is, well, we don't really care about, okay, yeah, we've got some labels and this is really, really bad. I really, really encourage you to not do this kind of stuff. Breaks and continues can even use labels. So you can say break to this point here. This is really, really similar to what we are used to do in very low-level languages such as assembly, in which you can go to a subroutine. You can jump from a piece of code to a completely different piece of code. This is exactly what we don't want to have in our high-level code, because we want our code to read as a newspaper article, very logically, a logic flow of information, and not jump around everywhere. But this code that I see here is also giving me a hint. As you know, you can nest loop ifs and else's inside of other ifs and else's. We did with the check login. Here we've got an if username with an if password inside of it. Well, you can also loop inside of other loops. And sometimes it's really, really convenient to do that, especially if you want to if you want to deal with grids, matrices, something that has a row and a column. Dr. Ignore says, I would like to give you a suggestion if you don't mind. Sure, why not? I'm quite new here, but I really like your content, but I think your strategy on YouTube is not correct. Your videos have lots of information, but I'm not able to know that without watching it. That means you should add meaningful titles like loops, conditions, episode names, etc. That's really true. I'm not really sure I want to keep the videos on YouTube, but yeah, we can talk about it. Also, your videos are so lengthy. Yes, they are. You should consider dividing it into parts and create playlists. Last but not least, you need interesting video thumbnails. That's true also. In my opinion, you will be very popular if you do those things. The only thing I don't agree with is the last part, because there are so many other YouTubers that create beautiful content in pills and with beautiful thumbnails, using the perfect kind of SEO. I don't want to do the same exact thing that they are doing. I'm pushing more on the live lessons more than YouTube. I just put my lessons on YouTube for people that missed my past lessons and want to catch up. But I'm pretty sure that I want to remove those lessons one day, because next year I will start the academy all over for new students. So I really, really prefer to focus on the live part, which I think is much more interesting. I don't see any live lessons for free out there. And I think that the added value here is the interaction that we have together. Also, there's a Discord channel in which we can discuss about the code, the problems that we have, and also share memes, so we can make a community of people that help each other. So I actually prefer to focus more on this, and the YouTube is just a backup for people that really, really need it. Speaking of which, if you want to join us, Dr. Ignore, this is the link that I'm sharing in the chats. Feel free to join us. It would be a pleasure for me to have you there. But your suggestions are really, really interesting, and we can discuss about them outside the lesson, because I'm open to suggestion. Of course, I'm rather new. I started this thing last October, my birthday. So anything that can help reach more people and help more people is more than welcome. Okay, let's go back to our code. So we can nest multiple loops together. And this is really interesting as an example. Look at that. For let I is equal to 0, I less than 3, I plus plus. And inside of it, for let j is equal to 0, j less than 3, j plus plus. Then let input prompt value at chords I, j. And I don't care what they say then. This is a nested loop. We've got a loop inside of a loop. And we can have loops inside of loops inside of loops. We've got loops inside of ifs inside of other loops. You can do whatever you want. It depends on the problems that you are trying to solve. A nested loop like this one can be a fun game. For example, we can do for let I is equal to 0, I is less than, let's say 10, I plus plus. And inside of this for, I'm going to do another for let j, because I have to use another variable name, is equal to 0. J is less than 10, because we want a square, and j plus plus. And now with these two things, we can console log, for example. We can console log, I don't know, let's do a template string in which we say the value of I, comma, the value of j. This is not going to look like a square, but I don't care so by now. So let's look at what happens if I execute this kind of code. One, two, three, boom. So I see all the possible combinations of I and j. I'm looping over I. But inside of I, I'm looping over j. So until I stop looping over the j loop, I'm not going forward with the I. This is pretty shown here. I, the value of I, is always 0, and I'm looping over the value of j. So given that I is 0, j is 0, then 1, then 2, then 3, then 4, then 5, etc., etc. And then, once I reached all the possible values of j, I'm now increasing the value of I, which is the outer loop. And I'm starting again with j, because if I start again the for loop, then j is reinitialized once again. So for I, which is equal to 1, j is now 0, then 1, then 2, then 3, then 4, then 5, then 6, etc., etc. And this goes on for all possible values of I and for j. Is it really that interesting? Yeah, it can be interesting, especially if I want to show some grid-like structure. Let's see if I can juggle around with strings, which you already know, and let's see what I can do with them. So for example, I can say let row is equal to an empty string. And then inside of this loop, I'm going to increment the row, because the plus, as you know, is an overloaded operator, so I can sum numbers, but I can also concatenate strings, and I can do it by incrementing a string with other strings. And I'm also going to put a space here to make it look better. And then at the end of this for loop, I'm going to add a new line character. What is this? This is really strange to see at first, but it's a common recipe that I used to create strips of strings that go then to a new line. And let's see what happens. I'm going to copy all this code. You see how tricky things are becoming as soon as you have the power of the for loop or any loop. This is what happens. Nothing, because I need to console log, which is something that I usually forget to do. So I'm going to console log the row. You know, actually, I probably don't even need to add a \n, which I also had to increment, otherwise I'm just replacing. And I don't need to add this \n because console log already goes to a new line. So let's make the code simpler. I'm just, for every single I, whatever the I is, I'm creating a new row, which is an empty string, and then I'm incrementing the row for every j that I find, and then at the end of each j loop, I'm console logging the row. And let's see this time what happens. Okay, it doesn't look like a square, but if I increase the size of the developer tools, you see that now it looks more like a grid. 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, etc., etc., and then 1, 0, 1, 1, 1, 2, etc., etc. What I've done so far is just placing all the numbers not one after the other on a new line, on a separate line, but I tried to construct a whole row of different j's that share the same I. So in this row, I is always 0 and j changes. In this other row, I is always 1 and j changes, etc., etc. Nested loops like this one are really, really useful to deal with grid-like structures, matrices, or I don't know, cells. somehow. If this doesn't make too much sense to you, let's try to make it more readable, for example. We can say that we have a number of rows, which is 10, and we have a number of columns, which is also 10. Well, this 10 here is the number of rows. I is an index, and that's why we usually use the variable name I, because I is an index inside of a loop or an array of rows, of a number of rows. And we use j because this is the common convention. If you have a variable called I, the other one is j, and if you need another one, you will use k, etc., etc. You could use a variable name called a instead of I, but I don't recommend it because it goes against the principle of least astonishment. You don't want to astonish your colleagues, your fellow developers. You want them to feel at home. And if they do for loops with the I variable and the j variable at most, just use the I variable. Don't come up with a strange variable name unless it makes things more readable. You can make it more readable. For example, if you don't like I, but you want to say that I stands for the current row, then yeah, you can call it row or current row. Provided that you change it everywhere. Make sure you change it everywhere. And this can make the code a little more readable. But I have a problem here because I already have a variable called row. So this has a clash of names and it will make my code not work. So I have to pay attention to the names that I give to variables. As you know, there are two difficult tasks in computer science. One is invalidating cache, which you don't care about, and the other one is naming things. You have to give meaningful names, and especially names that do not break the syntax, like in this case. You cannot declare two variables with the same name if they have a completely different meaning. So I'm gonna stick with I because it's the standard. And but at least I have this. I have rows. And this one too is columns. So j is an index that iterates over the columns of this grid, of this matrix. And this probably makes it a little more readable and also a little more user customizable. In fact, you can ask the user to prompt for a row. How many rows? And the same goes here. How many columns? And if you got this, why did I cut? I'm going to copy. If you have all this code, this is what we can do. How many rows? Just 5. How many columns? A little more, let's say 7. And now I've got a grid of 7 columns and 5 rows. This code is starting to become parametric, which means that you don't hard code every single number. You ask for the user for some input and it's going to perform specific calculations that would be quite difficult to do by hand. You don't want to write all these things by hand, of course. You want the computer to do it for you. And you do it with some nested loops. So in order to understand better what this row means, let row is equal to empty string. This is the initialization of a row that starts from an empty string and that will be incremented, accumulated with other pieces of string that will be concatenated to it. So in this loop, row is incremented with this thing here that we don't really care what this is. We could write it as we wish. But the fact is that this row variable is really, really similar to the sum variable that we already saw before. Or the result variable. Result starts with 0, result gets incremented for some reason, result is then printed. Here we are doing a similar thing. The row is initialized, the row is incremented, the row is then printed. The only difference here is that this initialization, increment, and print is inside of one of the loops. It's not outside of it. But we can do a little more than that. If we want to. I'm going to make it even more complex. Don't worry. You feel dizzy after this lesson, but really don't worry about that. I can even do something like let's call it I don't know, let's grid is equal to an empty string. So here we are declaring the whole grid. Let grid is equal to an empty string. Then in here, I'm creating the rows and I'm adding the row, incrementing the grid with the row and also a new line. In this case, I think I need a new line. So after each row, I want to go to a new line. Now the grid is a huge string that contains multiple rows concatenated together and separated each one by a new line. And finally, I can console the whole grid and hope that it behaves exactly like before. I have to also copy let rows and let columns here. And let's see what is the result of this. You see, I'm just juggling with the variables and with the for loops. It's pretty complicated at first, but this is what I would suggest you to do during this week. You have to play around. So how many rows? Again, 5. How many columns? Let's say is still 7. And now the grid is exactly the same as before, but instead of console logging every single row one by one, I constructed the whole grid and then I logged it at the end. Could you explain again how that plus equal after row is aligning the items next to each other? I think I didn't understand the command plus equals well. Of course, thanks for the question. Yeah, of course. So let's do this with numbers. Let sum is equal to 0. Now, if I do sum plus equals to 5, it means that the new value of sum will be the value it had before plus another 5. So this is exactly like saying sum is equal to sum plus 5. And the current value of sum is 5 because 0 plus 5 is 5. But now if I say sum plus equals 3, then the value of sum is not 3. It's whatever it was before, which is 5, plus another 3. So this means that sum is equal the value it had before, which is 5, plus another 3. In fact, the current value of sum is 8. You know that the plus sign, the plus operator is overloaded, and you can use it to concatenate strings. And the same goes with strings, in fact. You can start a string with an empty string, which is the equivalent of a 0 in the number world, because you have something that has no value. Or you can give it an initial value, of course, if you want to. And then you can say string plus equals hello, which is exactly the same as saying that the string is equal to the string itself concatenated to the string hello. And this is what happens. The current value of string is now the string hello. And you can concatenate even more, string plus equal to space there. And this will take the previous value of string, which is hello, and add space there. So you see, we are incrementing the string. And I didn't want to say hello world because I was looking for, what is the next string? You know it. General Kenobi. Hello there, General Kenobi. Well, it's actually two people speaking. Hello there, General Kenobi. Okay, from Star Wars. Okay, so this is how you can increment values. You can do it with the multiplication too. But the multiplication should be done on numbers, not on strings. But the same goes here. So the cool thing about this accumulation operators is that you can build a value in multiple steps, which is kind of cool. You can even calculate something like the average of your grades, which is actually a homework that I can give you. I'm not sure I want to give it to you because it could be too complicated. But the average of grades, how do you calculate the average of your grades? You usually say grade 1 plus grade 2 plus grade 3, etc., etc. And all of this should be divided by the number of grades that you have, something like this. If you want, you can even add weights but this gets even more complicated. So really difficult homework that I can give you is a program that asks the user for grades and grades and grades until the user doesn't want to add grades no more, and it calculates the average of these grades. It's complicated because it must take into account the current value of the grade that is input from the user, and it also should have some other variable that counts how many grades were input by the user. So this is pretty difficult, but if you feel confident, you can do it. Of course, remember, I'm giving you these difficult exercises not because I want you to do them as soon as the lesson is over. I want you to do them after you read the whole reference material and after you did all the tasks, and even maybe perform the tasks in the free code camp tutorials. And then, only then, it is convenient to try and do these kinds of exercises, which are really, really difficult. So grades. Grades is the new homework that I will assign you, and we can have a look at it next Saturday. I don't like giving grades. That's why I'm not doing it in this academy. But still, grades is an application that asks the user for grades until the user, cancels, and then calculates the average of all grades. I don't know if this is English, but still, the average is calculated like this. So we've got the average, which is the sum of all grades divided by the number of grades that the user put into the system. Now you can do this with the for loop. And you can do a lot of other very, very complex stuff, and we are probably going to do this next Wednesday. Things are going to get really, really tricky. And if you think that I'm going too fast or there's anything you don't understand, just like Angelo did, please tell me. I'm going to rehearse anything that is difficult to you or you just missed, because this is really, really hard stuff. So completely understand you. Now, developer tools. Let's do some debugging. Debugging was not really that important so far because we didn't have the for loop. But now that we have the for loop, then debugging could be crucial to understand what is happening inside of my code. So I'm going to create a new folder here called debug. And I'm going to create a new file, which is my index.html. So we're going back to the world of the web with a web page. Index.html, triple equals in order to have the whole. No, it was not triple equals, it was just a single equals in order to have the whole boilerplate code for the HTML page. And now we're going to add a script. This is something that you already know how to do. I'm doing it really, really fast because it's a quarter of an hour before the end. But I think you can make it pretty fast if you want to follow my code. This is a usual HTML page, which refers to a script that I will call debugme.js. Okay? And debugme.js is a file that I'll have in the same folder. It's called exactly the same, otherwise the reference is not working. And in debugme.js, I need to write some commands that are worth debugging. So I'm not going to write any new code. I'm going to copy and paste probably some code that is already there. For example, you know what? I'm going to use, I'm going to use this one here. Really, really complex. And that is worth debugging. So this is my code. Okay, so to recap, I created a folder called debug. I created an index.html with a script reference to a script that I'm going to create. The script that I created is this one, which is just a copy and paste of the code that we wrote just before. It could be any code, but at least it should have an if or a for, any conditional loop, any code that is not just a step-by-step thing, but it also jumps up and down. Okay, now that we have everything in place, I'm going to open this file with the index.html with the live server. And it's already asking me things, which is not what I wanted, but still. How many rows? 5. How many columns? 7. And nothing happens because I didn't alert these things. I console logged. So let's open the developer tools, and here's what we were supposed to see. Why did I do all of this? Wasn't it just worth it to use the copy and paste? Well, no, because now in the sources panel, I can look at the source code of my website, and I can see that there are 2 source codes here. One is the HTML, which is not exactly my HTML. It has other things that I didn't put in my HTML, but this piece of the JavaScript code that you see here was automatically added by someone else. It was added by, well, this thing here was probably added by the live server. Yeah, it's probably added by the live server, and I don't care about this. I really don't care. Let's go to debugme.js instead, and this is exactly the script that we already know. What do I do with this script? Well, this is a script that I can interact with somehow. I can even change the script, and you can see this is a dirty tab, and if I save it, the script will be executed as it is now, but still, it's not saving it into the file itself. So if I'm saving it, now debug.me is different, but the original file is still exactly as before. So we don't care about this. Let's see what Bobby says. Wouldn't it be easier if it's just printed on the page? Doubt that adding link deleted would make it more difficult for us. Link deleted. This is a new feature that I found. Since we had too many spam messages and I didn't want to block anyone that is not following, I decided to block the links only. So we will still be spammed, but we will not see links. So sorry, Bobby, if I cannot see your link. But still, this is one thing that's really, yeah, it's really an important matter. Is it better to print the partial result of things, maybe with some console logs, or is it better to debug? Well, debug gives you it is a very powerful tool. So I would suggest to debug. But yeah, sometimes it's really, oh, document.write, okay. Yeah, document.write, or probably even F ** probably is a bad word. So debugging is, I got it. So, as I was saying, debug tools are really powerful, but sometimes it's so convenient to just put a console log where you want to. And in fact, most of the developers that I know don't use debugging tools, and they use console log everywhere to see what is the current value of the variables that you have in that specific moment. But still, debugging is really powerful and it's really important, so we're going to do this. We have this debug.me code here, and here next to the line numbers, we can click, and you see that there's a blue marker. This blue marker that I can put pretty much anywhere, and I can just click and re-click to toggle the presence of the marker. Well, this marker is called a breakpoint. A breakpoint is a marker that stops the execution of the code until that point. And from there, you can decide if you want to resume execution completely, or if you want to take full control and go step by step in every single line, even getting inside of things and outside of things, but this is another matter that we will see with functions. But so far we can go step by step, and I'll show you how. As soon as you put a breakpoint, like in this one, like on line 2, I can refresh the browser, and you will see that if I put how many rows, 5, okay, it's not asking me immediately how many columns, but the execution stopped here on the breakpoint. From here, as you can see here below, it says that I have been paused on a breakpoint, and it lists all the breakpoints that I have, just one on line 2. And here I've got some buttons. This first button, which can also be shortcutted with an F8, resumes script execution. So I stopped here, but if I play this, it's just going to execute the whole rest of the code. But I can also step over the next function call, which just means that I'm going one step ahead. It's from code on line 2, it will execute code on line 2 and stop on code on line number 4, because 3 is actually nothing. It's just a new line. So it will step over line number 4. Let's do it. Step over next function call. Plof. How many columns? So it's executing line number 2, and I'll say 7. And then it's still stopping here. So as you can see, this, which can be done also with F10, or in my case, control apostrophe, control single quote, is a way to execute the code step by step, line by line. And the cool thing about this is that when you read the code step by step, you can, in the meantime, inspect the value of all your variables. So, for example, if I hover on rows, I will see that the value is 5. And if I hover on columns, I see that the value is 7. I don't need to print on the console log this value. I can see them right here where I am debugging. What is the value of grid? No value, because I haven't executed line 4 yet. So if I execute line 4 by stepping over, now I see that grid has a value. It's a declared variable and has a value of empty string. And now execution stopped at the 4. We also have other buttons here. Step into the next function call, step out of the current function. But as you can imagine, these are strictly related to the concept of functions that we haven't seen yet. So we will see these other buttons as soon as we deal with functions. And there's also step, which I think is really similar to the step over. But step over, as you can see, speaks about functions still. So if there is a function, it will just execute whatever is inside of that function and then step over. And this is probably exactly the same. Step is stepping, or probably not. Probably this is stepping inside of it. So now that I stepped, I see that the variable I should have been defined now. It doesn't say it's defined. Rows is 5. I is not. Is it true? I can even inspect the variable in the console. Yeah, I is valued and it's 0. Strange that it doesn't tell me, but it should be 0. Oh, okay. It's 0 here, but it's not 0 here. Okay, now it's 0 here too. Okay. Wait, so isn't there a debugger available for Visual Studio Code? Sounds like it would be way more convenient than setting up a new page for your project and opening it with a live server. Yes, exactly. You're way ahead every time. Yes, there is also a debugger for Visual Studio Code, which is exactly the same debugger. So you can debug, especially if you're creating Node.js applications. Unfortunately, this cannot be a Node.js application because we are using the prompt function, which opens a pop-up window, and this is not available on Node.js. But still, yes, you're completely right. We can do this on the browser, or we can do this on Visual Studio Code, and we will do it later. Next time maybe. Okay, so we can step. Now this row is undefined. We can step, and now row is defined. And now we are going to step over these statements. Let j is equal to 0 has not been executed yet, but with a step, now j has a value of 0. Is j less than columns? I don't know. Let's step. And now this statement was evaluated. And if I select the statement, the value is automatically calculated, and it's true. How cool is that? What's the value of j currently, j++? Nothing, because the increment, the step, was not executed yet. You know that this increment is performed after the body was executed. So currently row is still an empty string, but after we execute this code, step, Now row has a value which is 0, 0, because that's the value of I and j. And now I step to j++, which was 0, but if I step into it, now j becomes 1. And then I continuously check if j is less than columns. It is true. So we can step again and again and again. And at a certain point, you see that the value of row is increasing. It's concatenating more and more elements inside of the row. And finally, it jumped out of the for loop and it added whatever value was in row to the grid by concatenating the grid. You can also see the different values of the variables inside of here, which is probably more convenient than just hovering on every variable. You can just look at them here on the bottom right. So we can step forward, step in, step out, step a little more, or we can just resume script execution. And if I do it, boom, everything is there. Okay, so this is a really cool tool to understand what is happening if your code doesn't work. You can even customize the breakpoint, which is really, really cool. I can right click on this breakpoint and I can edit the breakpoint and I can add a JavaScript expression such as I should be equal to 4 and j should be equal to 2. If I write something like this, as you can see, the breakpoint becomes yellow because it's a conditional breakpoint. It's a breakpoint that will be executed only if some condition, some JavaScript condition is true. And if I now refresh the browser, execution will restart all over and I can say 5 rows, 7 columns, but the breakpoint stops here exactly when I is equal to 4 and j is equal to 2. So I don't even need to run through the whole loop. I can stop only when the variables are the variables that I expect. So as you can see, this is much, much, much more convenient than doing console log. The only alternative to this is if I really want to check what is the value of row. If I is 4 and j is equal to 2, I have to do something like if I is equal to 4 and j is equal to 2, then console log whatever is the current value of the row. But I have to do this changing my code, modifying my code, and maybe introducing more bugs. And maybe I just forget to remove this debug if from my code. So 5 and 7, and it's still stopping here, but I'm resuming execution. And I will see the console log being performed here, but it's not as useful as having these these breakpoints and even conditional breakpoints. So try as much as you can when writing code and debugging it to not use console logs inside of your code. Don't make it dirty. Just keep it clean and use breakpoints, debug with breakpoints. And then there's another really cool and important debugging tool, which is automated tests. And probably one day we will also talk about automated tests, but this is not the time. It requires a lot more things. If you want to debug on Visual Studio Code, yes, you can. Visual Studio Code, debug. The debug feature in Visual Studio Code is pretty much the same thing that you would expect. If I remember correctly, you just need to press F5. You select an environment, and we can use Chrome as an environment, Chrome Legacy. Let's try. And the problem is that you can see there's a configuration that was created automatically. There's a launch.json configuration here. Which makes things more complicated. Let's say that, yeah, we want exactly this. And now I want to debug this thing. And as you can see here on top, we have pretty much the same variables that you would see. This is the pause. This is step over, step into, step out. This is restart all over, completely stop execution. But I think it's not really working that well. Probably debugging Visual Studio Code is really useful if you are creating applications for Node.js. applications that do not require a browser. Because if you require a browser, and here we require a browser because we have the prompt function, then in that case, Visual Studio Code is still forced to open a browser in order to execute your code. So I don't think it's really that convenient for web application to use Visual Studio Code's debug tools, because we already have them in Chrome, and they are exactly the same developer tools that we have in Visual Studio Code. It's exactly the same base. For Node.js applications, you can use those debugging tools, and you just press F5 and you're ready to go. Select the environment, and that's it. That's it for today. There's a lot of information to swallow and digest. We barely scratched the surface. I have so many exercises to propose to you, but I don't want to give you too much for today. So please study thoroughly loops, because they are one of the most important parts and the most difficult parts of coding. It's the real meat of coding. And prepare, because with loops, we'll do lots of things. We will never get out of loops. It will be an infinite loop. Good lesson. Thanks a lot for your efforts, Anthony. Thank you guys for your effort in understanding my English and my lessons. Hope you guys enjoyed it. And in the meantime, eat pasta, code faster. Bye.